Morning. Hi, Jan.
Hello,
Hi, good morning.
good morning. Can you hear me?
Hey, morning.
Really well.
Yeah, can very well. You too.
Sorry, Laurent, I didn't hear you.
No problem. I just come 30 seconds before. So yeah.
Okay, yeah. Uh, Wait, why my camera is not? How are you guys?
Yeah, fine at home. So
We're
Mm-hmm.
fine, but at work.
yeah, no, we close everything here since yesterday. So
Oh, okay.
Wow.
yeah.
So it's for the vacation or just
No,
lockdown?
we have hard lockdown now until minimum 10 of January.
Oh, okay.
So all shops are closed except food, so on. But yeah, most of them are closed, and so the work we have to reduce drastically. Presence in school are also closed, so yeah. Yeah.
Yeah, we expect to have the same pretty soon. So
Yeah. I think it's almost everywhere the same thing. And Christmas is not the best for this, unfortunately, for this virus, for us, because yeah, we will meet a lot of people, or yeah, yeah, to control everything.
yeah.
Mm-mm-mm.
Hello, good morning.
Good morning.
Hi, Maricruz.
Morning.
Morning, everyone.
Morning. Somehow my camera is not working. Okay. Hmm. Yeah, I don't know why my camera is not working. But you guys can hear me well?
Yeah, I have no problem. I cannot see your screen. I have a black
Oh,
box.
good. Let me do it again. Now you guys can see it?
Yeah, I can, yeah. Yeah. It's working fine.
Bit slow. Let's just wait maybe a couple. Hello.
Hi, Ian.
Yeah, my camera is not working somehow.
Okay.
Okay.
We see you only on the boat.
Yeah, I think I'm streaming. That's why.
Yeah, I don't know. Maybe you have to turn off the computer. I mean, sometimes I have
Yeah.
problems. Supposed to run.
I guess now it's okay.
I don't see you.
Oh, okay.
Oh, I see you twice. Oh, there's a picture of, I don't
You see
know,
me?
some trees on a lake.
Oh, that one is the other me.
Yeah, and the other one is you on the boat.
Yeah. Okay. Maybe I will restart my computer
Yeah.
and join again.
Oh, now you're there.
I think I can start with my iPad first. Yeah, so.
You cut your hair.
Yeah, I did. How are you guys? Shall we maybe wait a few minutes again, like to allow more people coming? We now have 14.
Hey, Steven.
Yeah, just let you know, this one will be on live, and I will probably record it to have a better resolution after the meeting. That I will share it in the YouTube. hopefully you guys are all okay with it. But like for the paper drafting, I guess I will not share streaming it. So I think if everyone, we have 15 people right now. So I will just start to share my screen. You guys can all see my screen?
Yeah, it's perfect.
Okay, good. Yeah. So this is the schedule. And this time I think I asked the participants who has made quite a bit progress since last workshop and to present this time. And also at the end of the day, like 2:30, we can start to discuss the outline of the paper. And I have a first draft of the manuscript, but it's basically I've written the everything before the results and discussion. But for the results and discussion, I have put together all the bullet point of potential plots we want to include it in the paper. So I think first we can discuss about what's the storyline could be for this paper, and then we can go to more details about what we can learn, what we can read from the figures. Just let you know, if you have not upload your slides yet, please do so. Here's a link right there, and we will be streaming in the YouTube in this link as well. So here I summarized the progress. You can see now the first two columns, most of them are green compared to last time, but we do still have some data in process. I can go through something more specific for each data set in the coming slide. But like I haven't, so sorry if I didn't make it right about the last column, if it's finalized already, because I haven't have time to look into all the results you have submitted. I mean, not so many have been submitted, but like I haven't looked into each single one yet. But I think okay, here this is the plot. I think I have the rough idea how many data points are already have some rolling results, but some are still in process or ready for rolling. And I think two data set we do not have the seasonal solution yet, but the orange pie chart, I mean, it's not really a pie chart, but like it's the one to be done. Yes, they don't have the rolling result yet. The orange one is at least have the seasonal solution, or be soon have the rolling. And that's the rough idea about how many data I have got already. And so for the plans, I think more than less we have still follow the deadline, but I think which it might not be one thing might not be fitted is yet is like not all the stations have the preliminary rolling results ready by the end of November. But I think maybe if you can still at least make it done by the end of January, or be still possible. I still hope we can submit this paper by the end of March in our last workshop in March. And so for those data sets, which I think might be still have something to do, I have summarized maybe the plan. Maybe it's not accurate, but I think it's at least it should be could be give you an idea how close we are. So for example, the Berkeley's data, I have been working with Stefan since this month. I mean, maybe 3 weeks ago. I think he already get some reasonable seasonal runs, or be more than less ready to do the rolling soon. So for the Berkeley's data, for the Berkeley data, Stefan will present today, so we will find out. And for the Berkeley's data, I think Jenny and I have some discussions already about her rolling result. There are some problems about the 44 versus 43. I don't think it could be fixed, but maybe some of you can change my mind after she presented. I guess it's mostly because the overwhelmed people effect for her data, so there's no way to correct it. The 844-43 plot in her result, and for the top and in the from Excel's group, I think still the 29 signal, I think it's more still a problem, and I don't know if he has fixed it already. But so one potential solution would be to do it without the 29. I'm not sure if it's a good idea, but like it seems like it's the only way so far, because his 29 his switching system is maybe the offices and switch every 20 seconds, and I guess the 29 the air interference just blow up the 29 signal totally. So yeah, I don't know, there's another reasonable way to fix the data, but I hope if the blacklisting of 29 could still give him some reasonable solutions. So for the Heisenberg data, I think Datalystica has been more than less finished this results. And even though they don't have the time to present today, but they already submit the slides at least. And for Hutiala, I think Lina should already submit the results, but I haven't looked into it yet. And for the Costas, I think I have been working with Redec for like few months, and it seems to be very promising for me, but might be still need to improve the results due to the co-combustion factor. It appeared that in the summer it has larger mass concentration as well as the contribution than the winter for this factor, but other factor looks rather okay. We will find out after he presented his result today. And for the Lily data, yeah, I guess I probably pronounced there's a typo there. Yeah. I think I also work extensively with Hasna from Veronica's group. It seems to be she is very hardworking, and she made a lot of progresses, even though she only started like for a month of her PhD. And so I think she basically finished the seasonal results. It should be ready, and it seems like they can have 4 factors for the whole year, and I think they should be ready for the for running rolling PMF soon. And the Limelpeds, Samira is working on that during the STSN visit at the PSI, and also since last workshop. And I think she's still working with whether or not she can get to OOA in the winter. So I propose a way to fix this problem is just to run 2 OOA factors throughout the whole year. And I mean, just for winter first, and also run the 1 OOA factor solution for winter, and to compare the summed 2 OOA solution with the 1 OOA solution to compare the time series of those to see if they are alike. So I guess I don't know if this is a good way to do the differentiation, but it seems like the summed OOAs are more than less agree with the 1 OOA for the OOA factor. So yeah, hopefully we can get some inputs from you guys as well. And in Paris, I think Laila has been working on it, and she has sent me the 4-factor solutions for the whole year with HOA, BBOA, and the 2 OOAs. And I think now they do not have the problem of differentiation of the OOA factors anymore for different seasons. Yeah, but I haven't looked into the details of her result. I have worked just look at the 44, 43 price seems to be reasonable. We will find more details in her presentation. And for Evelyn's data in Pure de Dawn, I think she has the seasonal results more than less close to be accepted in a journal, and I think it should be easy to start rolling for 16-17 data. I mean 2016 to 17 data, but might need a month or so to get the rolling results if someone can work full time in your group. And for North Kensington, I've been working with Anna Font from London for quite a bit, and I think she has some rolling results, and I mean, and still struggling with the differentiation of OOAs in winter. It seems like it doesn't make sense to have 2 OOAs, and these 2 OOA are not so much alike, I think. And yeah, we were thinking about if the correlation between the time series of OOAs, I mean, like if you, for example, if you have 2 OOA factors, if you you make the hypothesis you will have 2 OOA factors, and then in the criteria you can you can monitor in the correlation of these two OOAs based on the time series or factor profiles to see if, as the differentiate criteria, to see if you have one or two OOAs. So this is another way we have been testing. She has been testing to differentiate during the winter. But I think we can find more details in her presentation. I hope also you guys can think about it. Then we can have more constructive discussion in this matter. And for Zeppelin data, I haven't started yet. I have been in contact with Venka from NILU. It seems to be quite time consuming to process the data so far, but I will work on that soon. Hopefully we can get something out. And for the Zurich, I still haven't looked into the seasonal results yet, but I think it should be rather straightforward. So that's the overall plans or for those unfinished data sets. So do you have any comments or yeah, so or questions?
Well, I think in general it's great to see the progress, and so it seems like nearly all the stations that we anticipate to be part of it will be able to be included, which is nice. I mean, maybe still have to. I mean, I think we said that we're going to decide today. I mean, somehow which sites to include, but maybe maybe still be one or two open questions.
Okay.
I mean, like the one in Zeppelin, for example. I mean, we've not even started totally, so
Yeah.
we'll have to see if that's really feasible. But yeah, I think it's good to try to keep still the deadline at the end of March, and just make sure we progress this paper as much as possible. You know, I mean, now it's still the time to do it, because I mean, most of the people in Europe, they can actually be at home around the computers and don't have to go so much maybe on new field campaigns or going to conferences and so on. So it's time to do this and finish it afterwards, when things get more relaxed, and also it will be harder to focus on this type of work. So I hope we can really get this done, and I think it looks really promising the way it has been progress.
Yeah. Yeah, okay. Or Maricruz, do you have any comments?
No.
No. Okay, very well. Yes, seems like we are maybe 5 minutes ahead of the schedule. But if Samira, you are ready, then we can start.
I think, yes, we can start.
Okay, I will stop sharing my screen.
So you can see the screen, right?
Yes.
Okay. Good morning, everybody. I'm Samira, and I would like to take this opportunity to talk about a bit source apportionment analysis on ACSM data from the Tropos Research Station Merpitz. The research station Merpitz is operated by the Leibniz Institute of Tropospheric Research, Tropos. The Merpitz site actually is a rural background site located in Germany near the city of Torgau, 50 kilometers to the northeast of Leipzig. The measuring field is situated on a flat meadow surrounded by agricultural land. And also ACSM has been permanently operated at Medved since June 2012. So first I'm going to present short overview. What is done is seasonal PMF runs for each season for 1 year, and from those runs we found that we can have a 5-factor solution for all seasons, which 3 of them are identified as primary organic aerosol. It means that's HOA, BBOA, CCOA, and 2 of them are identified as secondary organic aerosol factor, including SVOA and LVOA. And what is still need to be done is doing rolling PMF run for 1 year. Is doing rolling PMF run for 1 year, season by season, and then is to run 1 year full in coordination with the European overview paper from PSI. And in the end, working on complete ACSM dataset at least 5 years to do long-time source apportionment. Am I still here?
Yes, we can still see
Because
you. Sorry?
What I want to present today is a preliminary rolling result of 1 winter. So time period for our data is from December 2016 until February 2017. In this rolling PMF, I constrained primary organic factors. I used HOA from CRIPA, BBOA from Sally's reference, and I generated CCOA from our own data, and I used them by selecting random A value from 0 to 0.3 for HOA and from 0 to 0.4 for BBOA and CCOA, and also with bootstrap approach with 14-day window and 1-day shift with 100 repeats. And then in criteria part, I apply correlation between NOx with factor 1, level Kazan with factor 2, also explore variation of M over Z 60 and 115 for factor 2 and factor 3 respectively, and black carbon with HOA, BBOA, and CCO together. And in the end, I used sorting M over Z 43 and 44 for our OA factor. And well, here you can see the plots for this run and this time period. As I already mentioned, I constrained first 3 factors as HOA, BBOA, and CCOA. So in mass spectra plot, you can see them. The factor 1 is HOA, factor 2 is BBOA, 3 is CCOA, and the last 2 factors are our OA factors. But if we look at the time series and also mass spectral profile for these last 2 OA, it seems that these 2 OA look like similar, even they have similar diurnal profile in this plot. That's why I want go back a bit to show our bootstrap results and have a quick comparison between the rolling and bootstrap. So here you can see the F44 and F43 plot for both rolling in the left hand and for bootstrap in the right hand. As you can see, especially for rolling part, it's not really good because I think that maybe they're a bit mixing in this time, especially in this time. And if we want to see the mass spectra and time series and also diurnal profile and to have a comparison between them, we can see that in rolling that we can saw them in the previous slides. for mass spectra and time series and diurnal profile, but for Bootstrap, it looks good because they have a difference between these two OAs. And even in time series, for example, when this factor is increasing, the other is decreasing. And also they have a different diurnal profile. I just want to say that as a conclusion, I did one winter with 5-factor solution as a rolling with 3 primary organic and 2 OA, but still differences between the OAs splitting from Bootstrap and rolling remain unclear. And for the next step, I just want to finalize these for winter and then rolling for other season. And after this, fully 1 year in just one run. And this is just what I wanted to show you for today.
Thank you.
Yeah, thank you for your attention. I just want to know that if somebody have some idea or opinion about the rolling and Bootstrap, it's very welcome to her.
Yeah, I mean, the rolling and the bootstrap, even for rolling and the seasonal PMF, will be quite different in regarding of for the OOA. So when you compare this between the rolling and the seasonal, the OOA, it's supposed to have more differences for the OOA factors between the seasonal PMF and the rolling.
Yes.
So, in my opinion, here for your rolling results, your OA1 and OA2 is the same factor. It not only just seem to be alike in the factor profile, but also the time series.
Yes.
So, and I don't know. I mean, as I said, you also compare with this, like when you summed up this OA1, OA2, with the one you have only one OA rolling result, right?
Yes, I have them here. This
yeah.
This is 4-factor solution, and here you can see the correlation between them.
So, yeah, I mean, it seems to be basically the same solution. I think you just need the criteria to define when you can sum them up as a 1-factor. I guess it still be okay to run it with 5-factor solution, but at some point you have to decide. For example, as I said, for example, your OA1 and OA2 correlate at time series correlate very well. At some point, then you start to, you can start to say during this time you only have one OA. So do you guys think this is a good approach, or can you show the slide 11 to show the slopes and the correlation as well? Do you remember it? Okay, you have the slope in the very right bottom of the figures. Can you zoom in? Yeah, the slope is 0.92 and the R-square is 0.99. So the difference will be just for those period, the blue points. Those are really driven, make the overall slope smaller. What time is it? what time period are those points?
The blue points.
Yeah, right there.
The blue points is February.
Okay.
Yeah.
Yeah. Yeah, I don't know. I mean,
Beginning of February.
okay. Do you guys have any thought about this?
Hi, Ian. Hi,
Yeah.
guys. Do you think
Honest?
that they're so different that you actually need to include an extra factor? To me, they look so similar, even in the February season that you have the highest difference. Still, they look very similar. So maybe just go for one factor less.
Yes, I mean, the thing is we were thinking about when can we decide. I mean, I also agree it's a one factor, but I mean, the question is, do you think it's a good approach to do the differentiation, just to run the 2OA anyway, and to see if they are alike? If then they are alike, then you just sum them up at some point. Like one of the criteria could be done is just monitoring the time series of
Sure,
these
but
2OAs.
do you see any gain in doing that?
Yeah, because like so
Or the residuals
you
better for that period, for example?
The
that could be
residual
one.
for 5-factor solution is better than
Okay.
solution.
Yeah, of
that-
course, but it doesn't. It's just mathematically improved. It's not. It doesn't
Yeah,
make
but
any.
at least there is
sense.
some gain, though.
Yes, but also I don't know why Bootstrap, especially in time series, we can see the big differences between them. I mean, not that big, but yeah, it's clear that one is increasing, the other is decreasing, and also the diurnal profile is different. But for rolling results, I don't know why, what happened.
Yep. But in one case, you have a data set of 1 year and the other of 2 weeks. It might be easier if you have a larger data set to find some differences. The thing is if they're meaning something or not. I don't know.
I think here Samira, the difference are mainly driven by the differences of the the profiles. So but like I think the gaining of this approach is you can still run the same number of factors throughout the whole year. And this threshold or the criteria for differentiation, I think it's still rather not so subjective.
Okay.
And you can, it makes sense to me. I mean, if you, first of all, you have already tested, it's not so much difference between one OA and two OAs. I mean, the sum two OAs versus the one OA factor solution. And then it's still okay to sum it up. You might overestimate it a bit of the OOAs by doing so, but I think it's still reasonable within 8%. So yeah, that's that. But like you have to test it if the differentiate criteria works.
Okay.
You know, so this should still need to be tested.
I will try to apply different type of criteria for factor 4 and 5 into OA.
Yeah, I mean, if it works, then I think it should be one way to do so. Yeah, and yeah, okay.
Okay.
Yeah.
Thank you.
I think it's good. Yeah.
Any other idea, opinion from other people? If no, maybe I can stop the sharing.
Sure.
Okay,
Yes. Yeah.
thank you.
Thanks. Who is next? So next is Jenny. Okay, we are 10 minutes ahead. Jenny, if you are ready, then you can start sharing.
You can hear me?
Yes.
Okay, perfect. So I start sharing my screen. You can see my presentation now?
Yes.
Okay, perfect. So let's talk a little bit about our results. So some infos about our station. So we are located in Eastern Europe, nearby Bucharest, around 6 kilometers away. Bucharest is the most important city in Romania. We expect to have influences by traffic because we are located nearby the ring road. We also are located in the proximity of the Măgurele city, which is a residential area. But we have also agriculture fields nearby our site. The site is with the red star in the pictures. We analyzed the data for this experiment from September 2016 to August 2017. And we have gas phase information, also black carbon and some meteorological measurements. After several discussions with Jan and tries, we stick at the end with four-factor solution, and I'll show you why. So we took the traffic and biomass burning. We constrained the HOA using our local factor and BBOA using NG. We took random values for HOA between 0 to 0.3 and for BBOA until 0.5. And we at the end stick with 40 days window and 1 day shift and 100 repeats. We use the p-value of 0.01 for criteria based, and we use sorting for secondaries. These are the results of our rolling rounds, which from our point of view look quite reasonable for the entire year. And corresponding time series with fractions for each month. On the error estimation, the highest is for less oxidized factor, which is 37%, and then smaller for the other factors. Here is the distribution for each season and each month. And we are going to our issue then that Jan already explained at the beginning. We have an issue with F44 versus F43 model subtraction. As you can see, when we subtract all the biomass burning and the secondary factors, we have reasonable plots. But when we subtract only the secondaries, the F44 goes up to 0.5 or even more. except for the summer case, which is in the right side um, of the slide, which the figures are almost the same. It is not so dependent if we have secondary or BBOA subtracted. So we have this issue no matter what. So here are the runs with different number of factors for each season. So it's 4 for autumn, 5 for winter, 3 for spring, and 5 for summer. And as you can see, we have the same problem with F44 going up to 0.5 and even more. We have here plotted depending on the date and then on the concentrations. And you can see we have concentrations quite important, around 2 to 5 micrograms, which are above 0.5 for F44. And then in the summer case, we run it with 4-factor and then try it on Yannet device with 6 factors, so including also cooking and even cold combustion. And you can see for 4-factor, it's nicer than when we had it 6-factor. So this is one of the reasons that we stick with the 4-factor solution at the end. And here, because we thought on our discussions that this could be due to the fiber effect on our data, we run it for January, because this is the worst on winter is the worst thing with the signal corrected and not corrected for the fiber effect, and we have pretty much the same figures in terms of this F44 versus F43. So I think this is all from my side. If you have advices, they are really welcome. Should I stop my screen share or not? Yes.
No.
Okay.
Can you show the mass spectrum of the OAs?
Okay.
Okay. I don't understand how you can get values of F44 above 0.5, because I mean
me neither.
You should no, because the F18 is already the same as F44, right? So because that's fixed.
Yeah.
So it's impossible.
Yeah,
so
actually, Jan and even Francesco had a look on the data, because at the beginning I thought that I did some stupid mistake when I analyzed the data.
It can also be that Sophie makes some stupid mistake, but it's not possible.
But but we average and do it again the runs using different Sophies. So we used 6D and 6E, even the previous Sophies, to do all the calculations over and over, and we have the same issues except for the summer part.
Yeah, I asked Francesco to look into the data and his code. It doesn't seem to there anything wrong with the whatever the about the code or
no, but it must be wrong. I mean, it cannot be above. I mean, unless 18 is disregarded. But I mean, if it's in the, that's the only thing. I mean, if the ions that are calculated from F44 are not included in calculating the fraction. Then I understand you can have more than 50%, but otherwise it's just not possible. It's just wrong.
So, Benny, have you double checked if you also like excluded the 44 related variables?
Yes.
No, I mean, while you exporting your PMF input in ASYS local, did you?
No, this I didn't check. I checked that I excluded the 44 when I
in
ran
the
it,
SOFI,
the SOFI.
yeah, you did.
Yes.
But maybe I guess if you, so for example, if you don't have this 44 related variable at the first place, like, and then you exclude it in the SOFI. So basically you need to look into the original matrix, the original PMF input matrix to see if there are 16, 17, 18 variables there. So if there's nothing, then you could be the problem, I guess, but I'm not sure.
Must be something like that. I mean, if you look now, the F44 in the MOA, that's around 0.24. And I mean, can you go down to your F44, F43 plot? I mean, do we see the PMF? I think there was another one, or
Slide 9 or?
Yeah, I'm not sure.
Yeah, I mean, some of them are okay.
Yeah.
Yes. But something happened when I subtracted from the model only the secondaries, because when I took it all, it looks reasonable. And then when I subtracted only the secondary, it happens like this. So.
Yeah. But maybe you don't include somehow, then somehow the 18 is not there when you do this calculation.
Sorry?
Maybe you use a mass spectrum to subtract the primaries, and you don't start with including the 18 at the beginning when you do this calculation. Or I don't know. It must be something like that.
Yeah.
But what if, I think it's also, I think I myself and also Francesco checked the data.
Yes.
But
yeah,
we had
so
one
I don't
problem,
know.
But then it
Yeah,
was
we had the problem, but now this new version should take care of it. No matter what, like if you, even though you blacklist, then they will still take care of it now. So
well, but maybe you have to calculate for a specific point, I mean, to see what's happening.
Yeah, I mean, if
it must
you
be
have
wrong. I mean, there's no way that.
Yeah, if you have the experiment open, can you go?
Yeah, I have an experiment open.
Can you just check the original matrix? Let's just look into it.
Let's see. I have a lot of stuff in here. Sorry. Where? Okay. You wanted like the input?
Yeah. Can you? We are still in the slide.
Okay. Let's stop sharing and share the screen with the Sophie. I cannot see the Sophie. Sorry, I cannot.
Just share the whole screen.
Yeah. You can see it now?
Yes.
The experiment? Okay. Perfect. So you want to see, this is the.
Okay.
This is the.
It's there. Or maybe also
profile.
open your org specs.
Yeah.
Just to see basically the second and third columns. Yes. Yeah, it's there. I think it's not
Yeah.
excluded.
No.
So it's not a problem about yeah,
You
I don't know.
remember we checked even the signal to noise ratio, and then we use it the data done weighted in the original in the ACSM software, and then not done weighted there and done weighted only here, because we
Yeah.
thought that this is the reason at the beginning.
Yeah. But it's not, right?
No.
Yeah, I think 44 is not so, it's noisy. It must not be noisy. It's the most significant signal.
Yes.
Yeah. Here we really don't know what's the reason it's like that.
But why not choose a specific time point and make the calculation by hand?
Yeah,
Or,
we can
I mean,
do it.
I mean, not now, but
Sorry.
I mean,
Okay.
it needs to be figured out. I mean,
Sure. Yeah.
I don't understand how, or I mean, the only way it would be that some values would be negative, but usually in positive matrix factorization, we don't have negative. But otherwise, I don't see how you can get more than
not
50%.
You cannot be more than 50%.
Yeah, it's only if you would have
sense
negative contributions. Some.
Okay. Yeah, we can have another look.
Yeah.
I think, but we are somehow stuck with the data because we try all the things that we thought.
Yeah, but
is the
I
reason.
believe it's just some calculation error. There must be
Okay.
something in Sophie or whatever.
Yeah, we can. Yeah, let's. You can do the calculation for those. You can just, for example, find out what the time period for those points was higher than 0.45.
Sure.
Just find these points and do the calculation by hand. I mean, you can basically just do it from your time series of your 44, 43 and minus the 44, 43 from the POAs just to calculate it to see if they make sense.
Okay.
Yeah, just do it like manually and compare it and to make sure Sophie is doing correctly. Then if that's a problem, then it should be easy to fix. Francesco just need to have to do something on that. But if it's not, then we can talk about this later.
Sure.
Yeah. I don't know. I hopefully it's that simple to fix this.
Must be.
Yeah.
Okay.
I hope also. Okay. Thank you.
Thank you. So let's move on to Radek, if you are ready.
Yes, I'm ready. Can you hear me and see the slides?
Yes, but we are seeing the present mode.
Sorry, what?
Yeah, you can swap.
Can I start?
Can you go to the very top? There's a display setting. Display. You can swap the mode on the very top left. Display settings. Yeah, I think you have two screens, right? Yeah.
Yes.
The underscoring, you go to the display settings. It's on the very top left. Yeah, that one. Swap. Yeah, here it is.
Yes. Okay.
Yeah.
Thank
Thank you.
So, good morning, dear colleagues. Now I will present the results of rowing at the Rural Background Station Košice, located in the agriculture in the Czech Republic. The results of our modeling is a 5-factor solution with 3 fixed factors. One BBOA, and BBO is from our winter solution, and factor combustion is our emission profile. So we tested several possible solutions, for example, a 5-factor solution or a solution with HOA, or modeling of individuals' seasons separately. But this solution is best for us. Here you see the profiles and the daily courses of individual factors. We don't have morning peak to HOA. This is probably due to the distance of the measurements from transport sources, but we have typically afternoon peaks for BBOA and combustion factors. Here you see the overall causes of concentration of octane factors. Higher concentration of combustion factors in spring and summer are probably caused by better mixing of the boundary layer and due to transport of emission from coal-fired power plants or hotspots localities, and because our BBOA profile is more of residual heating factor, because people from the vicinity of Košice heat their homes mainly with brown coal and biomass. So these 2 sources are difficult to distinguish from each other. So there are error estimation of individual factors. Sorry. There are contribution of individual factors in individual season. The highest concentration of organic aerosol were detected in summer. The lowest in autumn. The highest concentration of OA, coal combustion factor, and low oxidized organic aerosol were measured in summer, and the factor more oxidized factor in spring. So here you see the results of the 44 versus 43 subtraction, model subtraction for each season, respectively for the whole year. And it's all. And thank you for your attention. Thank you.
Thank you.
Any question?
Can you show again the diagonals for the summer CCOA?
There, this slide.
Yeah, no. I mean, I think I asked you to plot something like the diagonals just for the summer for the CCOA, right? Just during the summer, for example. Here is the whole year. Here is the whole year, yeah.
Sorry, I don't have I guess yes, for summer.
Yeah, just diagonals.
Uh,
Yeah, exactly.
There is for summer and share of coal combustion factor to total organic acid.
Yeah. You usually UTC or
Yes,
local time?
UTC.
So it's the time zone there is 3 hours or 2 hours?
2 hours. 2 hours in summer.
Yeah. Do you think? Yeah, I don't know. Do you think it's a bit maybe? Can you show the HOA for the summer? Did you have it somewhere?
I don't know.
No? Yeah, I'm not sure if I asked you to do this yet. Yeah, I don't know. I mean, if it's the UTC, yeah. Andre, go ahead.
I mean, the concentrations in the yearly was very low, right? But in summer it's a bit higher. Did I get it right?
Yes, the concentration are very low, but in summer are highest.
I mean, in Poland when we had the coal factor, I mean, it correlated pretty well with chloride. So I don't know if you had a look at what 39 is doing or so. I mean, did you check the time series of chloride?
This factor non-correlate with chloride.
It didn't.
No, I don't think that they did. So Andre suggests maybe you can look at your external data of chloride. I mean, your AMS should measure the chloride at the same time. Then you can do to see if your CCOA correlate well with the chloride to say one of the justifications for this factor.
If I may
Yeah,
add,
I think, yeah, go ahead.
You might in summer, you might be below detection limit for chloride because it's mostly in the gas phase then.
Okay.
You measure enough chloride in the particle phase maybe. But definitely for winter you can check.
Yeah, winter very low. I mean, maybe it's just for whatever reason in summer that HOA and CCOA gets. I mean, maybe CCOA is more influenced by traffic as well. I mean, it looks like traffic more or less.
Yeah, but here I think I asked him to sort or evaluate the CCOA by 215. Is that so? The deck? The variable 215?
115.
No, it's not 115 because they have like MZ up to 300. So so we did it like based on the 215 instead, not 115 because 115 is more or less more explained by the. It's not so significant, this variable And it's not mostly explained by the CCOA somehow. Yeah, I think it's still quite a bit skeptical about the summer CCOA. You had this like HOA like diagonals. I'm not sure. Maybe you can try. Yeah.
Can show the we have the mass spectra of summer.
No, I don't have mass spectra for summer. Sorry.
But I think you
That's
did,
the one
right?
constraint.
I asked you to do that before, right? Did you? Have you done that, Radek?
No, we don't correlate this factor with chloride. We can do it.
Andre was asking if when you do the UNC, if you just the unconstrained PMF in the summer, I think.
Unconstrained solution.
Yeah, or even the constraint. I mean, if it's not strongly constrained, question if it moves towards a more HOA-like spectrum. I mean, I would look if the CCOA becomes more HOA-like in summer. It's unlikely that it's CCOA, right? In some. I mean, do you have external data for? No, probably not. That correlates with HOA or traffic. You don't have a traffic indicator, NOx or.
I think they have the BC traffic.
BC traffic. I mean, have you tried to correlate HOA or the sum of HOA and CCOA with BC traffic to see if the correlation improves if you add both?
Yes, we have. For summer, just correlation for summer are there.
Yeah. My question was if the correlation gets higher if you, for example, add HOA and coal together and correlate it with BC traffic. If the correlation is higher than with HOA alone, then that would be maybe a sign that maybe basically the CCOA will be a split of CCOA HOA is a split of both HOAs. Just an idea.
Yeah, maybe it's worthwhile to try the multilinear regression.
Yeah, or just use the sum to see if the correlation gets higher. That for me would already be quite a good indication.
Yeah, but I think now also the problem is in the summer, the CCOA have like larger mass concentration than the winter. I mean, overall their data have more mass concentration of organic aerosol in the summer than the winter. That's also one of the reasons causes this, I guess. Yeah, but overall, still the CCOA concentration is still very low throughout the whole year. Yeah, those. I mean, I guess I think somehow I tested for the summer. In my perspective, I think it makes sense to have the CCOA, but we just need to figure out how we can, get a reasonable, like CCOA. I guess maybe Radek, one thing you can still try is when you just change the criterion for the CCOA using maybe another variables.
Okay.
Like just you may need to look at. I think I sent you a paper saying what kind of high mass to charge ratio can indicate to the could be the fingerprints for the CCOA.
Yes.
So you can check the diagonals for those key variables for first, just for summer, to see if they are a good candidate for the as the criterion. For example, if your 215 show also like traffic like patterns, then you should not use it. But if some of the high mass variables just shows like reasonable diagonals, then you may use that as the criteria, like as a explain variation of that variable. Then and the problem could be solved, in my opinion. But yeah.
Are the high MZs actually included in the PMF, or are they only?
Yes, it's included in the PMF. It's up to 300.
Okay, then it's good to show us the mass spectra, maybe in a logarithmic scale, and including the relative contribution with the stars.
Yeah, yeah.
See the full range of the MZ to see. I mean,
yeah, I think the CCOA. Yeah, the CCOA factor overall, it explains most of the variables in high MZs. That's also one of the.
But also in summer.
Yes, yes. Okay. That's why we think it's still feasible to have this factor in the summer at the first place. Yeah, but like I think what you can do is just maybe just look into this high MZs again to see if it's
okay.
Could be a good criterion. Yeah.
Okay. I mean, this site you said it's more organic in summer than in winter.
Yeah.
So is it on a hill or something, this site? Or not? Or is it really in the flat terrain?
Maybe can you go back to the first slide, your introduction slide? I think it's a tower, right? It's like a 30-minute above the.
It's a bit of a hilly area. Yeah, okay. Maybe in winter you're kind of a little bit above the haze a bit. No.
Yeah, it may happen.
Yeah. It's probably the reason.
Yeah, I think they applied CDC, and seems like they have smaller CE value in the summer and spring.
Yeah.
Yeah, but I think they have making quite a bit progress. So
yeah, no, I mean it's not impossible that all the concentrations are higher in summer because of the meteorology. No, but still a bit weird that it's so much cold. Are there any? Well, this doesn't look like there's any. It's quite rural. No industries close by. Good. Yeah, I think those suggestions you gave are good.
Okay, thanks.
Okay, thank you.
Yeah, thank you, Radek. So maybe one thing I should remind you guys for whoever is using the version before 6.d for evaluating the criteria. So those of you should be very cautious. Maybe you should consider to reevaluate your criteria. I think Sophie has had the problem on the p-values calculating for a previous version. So just to remind you all, if you have evaluated your criteria using the previous version before 6.d, then you should reevaluate it. Anna and Francesco found out there was some problem about the previous versions. Yeah, but like I guess most of your results were finalized using the rather latest version. So it should not be a big problem, but it's still worthwhile to mention it. Just make sure you have done it correctly, because we really recommend it to use these p-values. So it's very important to make it right. Yeah. So do you guys still have any comments? And if not, we can have our first coffee break, and we can come back at the 11. Or just if you have any comments, you can just talk right now. No? Sounds good. Then let's meet at 11 in 47 minutes, 37 minutes. Hello, guys. Can you guys hear me?
Yes.
Yeah, I can hear you.
Yeah.
Just to
Yeah,
let you
and,
know,
yeah, thank you.
before we start, I'm only here for a couple of hours. I've got an examination to do this afternoon, but I thought I'd swing by for part of this morning.
Oh, nice to meet you, James. So Anna,
Yeah.
would you like to share your screen now?
Yeah. Okay. Can you see it?
Not yet.
No?
No. Can you try it again?
Yeah. Let me see.
Yes.
Yeah. Okay. So I'm going to present, well, since the last workshop, I've been working on finalizing the seasonal solution. And I start looking at the rolling PMF at North Kensington in London. So as a just for you, as a reminder, so North Kensington is a monitoring site located in inner London, so it's quite urban. It's located in a residential area, so it's not very close to any big road, but mostly close. Well, there are some residential streets around, and mostly there's a school nearby and some residential streets. We have SCSM measurements from December 2015 to February 2018, but I've been just looking for the PMF. I've just been looking at the last year from December 2016 to February 2018. So that comprises 2 winters. And the site has also some collocated gas measurements and also black carbon. So for the seasonal, in the last workshop, I was showing the results using the constraining the profiles using the CRIPA profiles for HOA, COA, and also BBOA. But it looks like that factor was very oxidized itself. So following Ian's suggestion, I constrained BBOA using some kind of our own BBOA extracted from 50 bootstrap runs using the winter 16-17. And for that one, before I constrain it by the Salis profile, I use the random A value from 0 to 0.4, bootstrap enable and 100 repeats. And this is the list of criteria. So I look at the correlation between HOA and NOx, and I look at for P values below 0.05. For BBOA, I look at the correlation between BBOA and BC boot burning, and I look for values lower than 0.5 and 0.05. For COA, I look at the ratio of concentrations measured between noon and 1 and 10 and 11, and I should be greater than 1. And I sort MOOA as the factor with the largest fraction of F44, and I look for LOA based on the F43 values. Here are the 2 profiles for the 2 winters that I'm considering. And for the first winter, well, there's the 3 primary factors that I constrain, and then there's a more oxidized OOA. That's the one here, and then I could see that there was a second LOA factor that it has quite a bit of F60 in there, and it will be more like an HBBOA factor, and as it mirrors a bit with the BBOA factor itself. But for the second winter, I could not distinguish these two OA factors, and I just had a general OA one. And so those will be the error profiles for the first winter, and the slopes they are quite low, below 20%. And for the OA factor, like the combined with the MOA and the HBBOA will be around 30%. For the second winter, that will be the error estimation for every factor, and they are quite low, even the OA factor in here. That will be the time series for the first winter, and the diurnals, they follow like as expected for each of the factors. That will be the time series for the second, and as well the diurnals following like what we would expect. And for the spring one, so here also I could distinguish two OA factors, one more oxidized and a less oxidized one. And so those will be the error profiles, and they are quite low in general for all the factors below 20%. And that will be the time series for the different factors. And yeah, they quite follow, well, especially the diurnals, they will follow what we were expecting. For summer, as well, two OA factors, and there are two OA factors, and I didn't not constrained for BBOA, and that's just really looking at the F60, but I still have to try to see if I constraining for the BBOA factor, that will reappear, and maybe just to see if it's very low. But for the seasonal solution, I just prefer to put it like that. And that will be the error profiles. They are quite low as well, with exception or a bit of exception of the LOA factor, that is about 24%. But still, like looking at the slope and the distribution of the points, they look quite. For time series as well, this is they expect more or less what we would expect that they are doing. And for autumn profile, here I tried many times to see if I could distinguish also two OA factors, but I couldn't see that they were not making any sense when I was trying to force for a second OA factor. So I left it like that with just one OA factor. And that will be the different error estimations, that they're quite low for the different factors, and that will be the time series. So that will be whatever. I know that I've been going through very quickly, but that will be the seasonal solution. So for one of the winters, I could distinguish an HBBOA factor that I've been naming like a general LOOA. And from spring and summer, I could distinguish two OA factors as well, but that was not the case for the autumn and for the second winter. And that will be the separation of the two OA factors in the F44, F43 space. And I think that they look quite nice in the sense that the first in the first winter that I could distinguish the two OA factors, that's more towards to the left part of the graph, while the spring and the summer, they are more towards the right part of the graph, and that will be something that it's expecting. That's more oxidation of biogenic sources, and that will be more like the oxidation of the combustion sources. So what I was saying that, yeah, I mean, there's this challenge of like there are some seasons that I could just distinguish one OA factor with just looking at the seasonal profile, the seasonal solution, but there are other solutions, other seasons that the 5-factor solution is the best one. So that it's a bit of a challenge how to distinguish these, like the periods with these two OA factors. So, well, I've been running some PMF and focusing on the 2017 using 14 days window, 1-day shift, bootstrapping enable, and I'll just start with 5 runs to start with. And this is the list of criteria that I use. So I use the ones, like the first 4 ones are the same as I used for the solution, but I added this one following some long discussions with Ian. So see if we could distinguish these 2 periods of of 4 or 5 factors if we were looking at the correlation, the MOA and the LOA, and give like see if we can distinguish or define a threshold that we can actually give to distinguish these two OA factors. That will be the time series of the correlation between the factor 4 and factor 5. And you could see that it's quite, there's quite a lot of values itself, and it goes from 0 to almost 0.9. And it looks like, even if the values, they are quite spread through the year, like in the warmer months, there might be more periods with low correlation values. So that might be an indication that maybe when the R-square is below, let's say 0.4 or 0.2, that will be more, that will be when we have like this MOA and LOA factor. And for the other periods, like the higher values, they might be when we have the HBOA factor. But looking, that's looking at the seasonal solution. Yeah, I mean, the LOA factor, that it's named as LOA, that it will be more a HBOA factor. It correlates quite well with the BC wood burning, and the two OA factors doesn't correlate much. But then in the seasonal solution, the LOA and MOA, and they correlate quite well. So, that's something to bear in mind, but that might not be representative either for the rolling solution. So I've been just looking how the profiles look like, where the R-square of the factor 4 and factor 5 are below 0.4 and above 0.6. So for the first case, there's about the rolling PMF is simulating about, let's say almost 21% of the data points, but there's still quite a lot of like missing time points, about 17%. So those are the two, either three primary factors, and then the two in the sense of the two OA factors, they look they split quite well and they look quite sensible. So we have like an MOA factor and LOA and an LOA factor as well, but it's quite oxidized as well itself. And for the R-square is above 0.6, while in this case, there's not much data point that it's simulated. It's just about, 3%. And there's as well like quite a lot of missing points. So, and if we look at the two OA factors, so this, the LOA, it might be more, it has a tiny bit more of F60 as well, and is less oxidized when we compare it where the R-square is below 0.2. And just also like to have a look at how the time series look like. So that will be the time series for and the diurnals for when the R-square is below 0.4, and they look quite okay. And that's when they are above 0.6. Then I look how the F44 versus F43 space looks like. And obviously because it's a rolling, it's quite messy, but yeah, I'm quite confused. So when it's R below 0.4, it looks like that mostly all the points are tending towards the right part of the left part of the graph. So that will be more kind of combustion related sources. And for the R-square above 0.6 is actually more towards the right-hand side of the graph. So that will be looking more like at the biogenic sources. And that will be also like looking at the correlation. It's just because I'm not very sure if this is actually a good criteria or yes, but it's just like just looking and experimenting a bit. So that's when the R-square is below 0.4, and I have the issue that it's the BC wood burning is actually quite well correlated with almost all the factors, and that's not the case when I'm just looking at the seasonal solutions, it's just factor 2 that is really well correlated, and that's actually the same for R squared above 0.6, and that will be me for the time being. So yeah, so the point that I'm here now is just to how we can try to find a good criteria to select. It looks like that there are two LOOA factors, and they are quite different. So the one in winter is more an HBBOA factor, and the one in summer is more like an oxidized based of the biogenic sources, but I'm not really sure how to distinguish them in a rolling exercise. So if you have any suggestion, that would be great.
Yeah, James, you can ask questions.
I
You
heard
raised
that.
your
I was
hand.
like,
And also Stefan.
yeah. There's something hauntingly familiar about the previous work that we did in London, because it seems to me that a lot of the problem is that, particularly in the winter, the OOA factors are absorbing a load of the variance off the biomass burning factor. And now I'm just trying to think of a helpful suggestion here. I mean, there was that paper we did a few years ago where we actually got 2 biomass burning factors out of London, but that was with a high-res AMS, so that doesn't help you. I'm just wondering if there's, but I mean, that would all be tying completely with one of your, I mean, the LOOA factor starting to resemble the wood burning factor in winter. But I mean, the other thing was that we weren't able to get 2 OOA factors in winter. I mean, the suggestion we had at the time was that we should possibly have 2 target profiles for the biomass burning, for the wood burning. But that was purely hypothetical because we didn't have any ACSMs in the UK at the time. I don't know if you've tried that, have you?
I haven't.
But that would be a lot of work and would probably involve completely re-engineering stuff and things. So I'm not so sure that's a good idea or not.
But it's true that I can try to, for instance, using the seasonal solution.
Sorry, I couldn't hear you then. Your voice has gone distant.
Sorry. If I use the seasonal solution for the first winter, that will be this LOA factor here, but that it's more like an BBOA factor. I can try to use that factor to constrain in the rolling PMF. That will help as a kind of like.
Yeah. So, sorry to interrupt, but let me just ask James. So I'm wondering. Yeah, I haven't read the paper you mentioned before, but how different are those 2 BBOA factor profile looks like?
They're a bit different. They're not hugely the profiles derived from ambient, they're a little bit different, but not hugely different. But they were different enough to account for a lot of the variance in central London. The 2 factors that we got were fairly covariant, not perfectly covariant. But the thing that was really important is that when you looked at the difference between the 2 profiles, like one had, higher F60 and there was like different 44, that kind of thing. But when we did a subsequent experiment where we're doing controlled burns on wood, we saw the exact same difference in the pyrolysis and combustion phases of the wood. So we think that what that was representing is real chemical variability in the London data set, just subtle changes from kind of different kind of burning phases in domestic stuff. But I mean, we didn't actually get anything real out of interpreting the time series from it. But what it did do is, we think, give a better solution for the biomass burning by giving it effectively 2 factors instead of 1, much like analogous to the way that you get better accountancy of the secondaries by getting 2 factors instead of 1. But like I said before, this is with a high-res AMS, where you've got all this extra detail to play with. I mean, what we could do in theory is take the target profiles we got from London in our previous paper and apply that in here. But that would, I've no idea. That, like I said, that was only a hypothetical suggestion. I don't know if it'd work or not.
That wouldn't be so hard. I mean, we could take them as reference profiles and just recalculate it for unit mass. And that wouldn't be so hard. I mean, how much is the BBOA again in winter? Is it a big fraction?
I haven't shown it today, but it's about, yeah, it can be, well, for instance, here it's, I mean, I would say that it's just, this is, well, maybe if I do it better. This is kind of like, that will be LOA, but that will be the HBBOA. So yeah, that's it's quite a bit chunk. And that's for the second winter and the autumn. So, I mean, it's quite significant, I would say.
I mean,
and I guess that here
it's fairly taken. I mean, it's also in, I mean, the data set Ian was looking at Magodina, where biomass burning is very important in winter. Kind of needed 2 factors there as well to explain. Just seems like, I mean, just factors that are very dominant. Maybe you want to have 2 factors explain their chemical variability changes. So I think this is,
if it helps,
it can just happen. I mean, that's normal.
I mean, I don't know if those factors ever made it onto Jose's database or not, but if it helps you, I can try and dig them out if you want.
Yes.
Yes.
I will do that.
Yeah, I'll call that an action then.
Yeah, I can try to to constrain it for the see.
You can still
but like
play around with the A values.
Yeah.
Yeah, but the thing is here, I think it's for this winter, for example, I think it already make a lot of sense. The BBOA Anna got here is from her unconstrained PMF. So, I mean, it's a fresh BBOA apparently, and I mean, and also if in the LOA, it looks like it's HBBOA, and she also tried to constrain the CRIPA, the Paris BBOA, which has higher 44 than 43. So when she trying to get to another OOA, then the LOA will looks like a fresh BBOA. So it's basically you do have this 2.
I really wouldn't think of it in terms of fresh and aged. For our paper, we spent ages trying to drill into that. It's all fresh, basically, but you just get enough variation in the emissions profile, and it can all but just be explained by, you know, combustion conditions and things like that. I can send those references out if you want. But when we previously looked at this in London, we were kind of really doing effort to try and see if it is a kind of an aging thing. And as far as we can tell, it's not. It's just all fresh, but it's a very variable fresh, basically.
Yeah. But in other cases, you know, James, we have, I mean, it was difficult to, I mean, usually when it split up in 2, it was often a little bit, one was a bit more aged than the other, which is, I mean,
yeah, I'm just
possible, depends on the data set somehow.
Oh yeah, this could be something specific to London. Don't get me wrong here. I mean, in fairness, this is the only data set where we've seen this happen before. But it could be a specific thing to London, because it's worth, I mean, 2 factors is that one is that biomass burning is a big factor in London in the winter because we don't have much of an organic background, you know, particularly in a westerly. But the other is that a lot of the wood burning emissions are not very well regulated. you know, something that Gary Fuller's been going on about a lot. So, you know, it could be that we are just got this really messy, dominant biomass burning source.
Okay, can we go for a different topic? So could you show the error graphs one more time?
Yeah, well, those are for the seasonal one.
Yes.
Yeah, so that will
sure how the
be.
winter look like, but the okay, yeah, maybe can you show me the autumn?
Autumn.
I mean, here I have a feeling that, I mean, there's some points are really off.
Yeah.
Having more errors, and I don't know. I think I would investigate a little bit what these are. I mean, what these time points are, and maybe look at the residuals during this time if there's something special going on, and see if those points influence your solution quite a lot. I don't know.
I have the feeling, but that's just a feeling. I mean, that's not looking at those points specifically, but because it's like towards the end of the season, because well, the season goes from September to the end of November. I think that there's a large variability in terms of temperature and as well of the sources. And I have the feeling that these OA factors that taking the 3 months data, I could not see match this HBBOA factor, but I have the feeling that some of those points, they are actually BBOA related because that's towards end of November. You know what I mean?
Yeah, okay. You can check if in the rolling these, I mean, the error of those points already getting reduced a lot, then it's fine. Otherwise, might be good to look specifically at those points if there was something special going on that maybe, I don't know, maybe you had some local stuff going on around your station that maybe, or something. I mean, I would at least check.
Yeah.
I mean, what I'm a bit worried is, I mean, the amount of data you lose. I mean, you lose a lot of data, right? 10, 15%, or how much was it?
Yeah, when I'm looking at the R squares.
Okay. Aha.
That's when I because I'm just trying to see if I can define a criteria when I can distinguish the two different LOA factors, and but maybe that's solved if I can try to constrain by this second BBOA. I'm not going to call it HBBOA, but yeah.
I mean, what is striking to me in the lowest profiles is the high 15 in the left.
Yeah, the 15, I think it's rather
high fraction 15. So
yeah,
I'm not sure. Do you think that's an instrumental issue, or is it? I mean,
well, I'm trying to. Well, I've discussed that with Ian, and he said that he removed F15 on his run. So I've been trying to do that, but I have something going on with Sophie, and I asked Francesco. So the new PMF without the F15 should be coming soon.
okay.
But yeah, I mean,
it could be that, I mean, this is still influenced by when you change the filters, and somehow you get a bit weird values there.
Yeah.
I mean, it often happens for low NZs with the QAC somehow. So yeah, I would be, I don't know, be cautious. Or I mean, if 15 is important in driving some of the things you're seeing, maybe that's, I mean, it would be good to eliminate it and make sure that things stay the same. Okay.
Yeah,
I mean, the signal is anyway noisy.
Yeah.
Okay. But it might, it's still a big signal, so it might still influence your solution quite a bit.
Yeah.
Yeah, I'll compare the results without the F15 and see. Yeah.
Okay.
Yeah. But
So,
yeah,
but like, are you guys happy with the way to doing the differentiate. That's I think that's one of the most important topics we want to discuss today as well. It's not just Anna and Samira also has this problem. I guess we should, if you guys have any thought regarding this approach, just say so. Or should we? Does Stefan has a question?
Yes, can you hear me okay?
Yes.
Yeah.
You can. Maybe it's on a simpler level, but if you were to do a 4-factor solution in place of the 4-factor solution, would the OOA that you presumably get out be roughly equal to the sum of the more oxidized and less oxidized OOA you get from a 5-factor solution?
It will be more, I mean, it will be the addition of them, but it's obviously, it will be look like more like a more oxidized OOA.
Yeah, so I think Stefan's question is more like when you sum up this MO and LO in this 5-factor solution, are they look alike for the 4-factor solution?
Yeah, exactly.
With only one OOA. Have you tried that?
I've tried that. I can dig up the results.
Because and also like a second follow-up to that would be, could that be an optimization you could do, so you can find 4-factor solutions where it's approximately equal to the sum of the OOA factors in the 5-factor, and then you would have the same number of factors for all of the seasons, and it would be much easier.
Yeah, that's basically what the Samira has done. So you can try to compare those, yeah, I think in her data, her LO and MO, some in the winter specifically, are very much correlated. So if that's the case, that I think it could be a good criteria to use as a to indicate, oh, at what time point you should have only one OOA. When you only have one, then you just sum them up in the solution, in the final solution. Then that's it. I think.
Because that should also provide you with a nice point of transition, because otherwise, if you don't have that criteria, you will have a jump in the mass of the primary factors when you move from between 4 and 5. Whereas if you make the transition exactly there where the sum of the 2 factors starts to diverge, that should keep the masses, yeah, maybe closer together. Or you just run 4 factors. I mean, otherwise I don't see how to do this rolling PMF.
Yeah.
Yeah.
Yeah, the only thing is that, well, it's kind of a pity to lose this information of like having 2 factors and just one OOA factor. But yeah,
you could still provide it actually. I mean, it's always a representation of the data set that you have, right? I mean, even if you run 3 days of PMF, that's still an average representation of that 3 days, I guess, like on a sort of more philosophical point.
Yeah. Yeah. Yeah, I can just maybe try to go for the easiest way, and it will be just to look for 4-factor solution, and then.
Yeah, I will certainly do that. Maybe you can just start with running the rolling with 4 and 5 just for the winter 2017. I think first, just try to do it for one season first to see if it makes sense to, if they are very much different between the one OOA solution and 2 OOA solutions. If they are not, then I think it's still okay to do so. To have like 2 OOAs and then sum them up afterwards. So I think, yeah, I don't know what do you guys think? What others? How about you guys? I mean, do you think this is a good approach or any comments? No? Okay.
Well,
very well. Yeah, I think we should move on. We are a bit late.
Too much.
Yeah.
Sorry, guys.
But thank you very much, Anna.
Yeah.
So let's move on to the next. Laila, could you start sharing your screen, please?
Hello, yes, I can. Okay, 1 second.
So Laila will talk about her data in Paris.
Okay, can you see my screen?
Yes.
And can you hear me? Yes, I guess.
Yes.
Okay, great. So yes, as I just said, I'm going to talk about the data in Paris. I mean near Paris. So our site is located in a suburban area near to Paris and at the Sutter station, and we've been having long-term ACSM measurements, and the data set is from January 2016 to April 2017. And yeah, just to say that the station is a regional background, but also has some influence from Paris, obviously. And so I continued with what I did before with the rolling PMF, just that this time I finally enabled the bootstrap. So yeah, I still use the SOFI version 6.8, HOA and BBOA constrained with CRIP-IDALS profiles. We use a value from 0 to 0.5 for HOA and 0 to 0.8 for BBOA, and 28-day window shift with 100 repeats. And I used the same criteria, so the ones from the protocol. For HOA, the correlation with BCFF. For BBOA, the explained variation of the MZ60. And yes, and sorting MOA and LOA using F44 and F43, and also still the square root to differentiate both. I mean, and anyway, and to sort and differentiate both criteria with yes, F43 and F44. And before coming to the results, I talked with Olivier yesterday about the results, and I mean about everything, and and we looked at how the criteria looked. And I mean for HOA and its correlation with BCFF, we can see that using the t-tests, we have like it selects. Doesn't select a lot of values for summer, so I don't know if it might be a problem to simulate also the runs for summer. And anyway, I'll go on and maybe we will come back to this afterwards. And yes, so for the results, I think it looks quite the same as before I was using the bootstrap, so it's kind of good that with the bootstrap it showed that the results are the same, so they must be okay, I guess. Anyway, I think the OOAs are now quite well differentiated, because for LOA we can see 43 and 44, and for MOA mostly 44 and 44. And also they don't contain a lot of F60, so they are also differentiated from BBOA, and also from the diagonal profiles for HOA and BBOA we can see like here the double peaks and the peak in the evening. For the time series and contributions, yeah, exactly. So yeah, the time series look like this, but for the contributions, we can see that BBOA always contributes quite a lot. I mean, significantly, and also in the summer. So this is also a question that we have if it might be a bit weird that contributes at least the same as traffic. I mean, as HOA during the hotter month. For the error estimation, we have 19% for HOA, 18% for BBOA. 40% for LOOA, 32% for MOOA, and 21% for the sum of both OOAs. And yes. And for the contributions for the different seasons, so as I said, for spring and summer, BBOA contributes for about 10%, so even more than HOA, and otherwise the greatest contributions are for both OOA factors. Here, if we have the contributions, but not the relative contributions, we can see that well, there was a pollution peak in December 2016, so we can see that it's much higher, and also that BBOA in total contribution is higher than for the other month, but still quite high. I mean, quite significant during the warmer month, and yes, and during the winter, BBOA contributes more than in the other seasons, comparing to the other factors. And here the F44 versus F43 plots. I guess the more we can see the separation of MOOA and LOOA because I plotted both, and the differences for the 4 seasons, and well, the plot for the whole period is a bit more messy, but we can still see a little bit what it gives. So yes, so I did the rolling PMF over 1 year with the bootstrap. We still have the 4-factor solution with HOA, BBOA, LOOA, and MOA. But since I don't really look at each season specifically, it's just like the mean, the average solution is on the whole year. So maybe this would be a bit messy for HOA and BBOA during the summer. Yeah, so I don't know if you have questions or ideas about this. And thanks for listening.
Thank you very much. Laila, could you go to your slide 4? So I'm wondering how many missing points in the end for these results you have. How much percent? You can go there.
Yes, I will go because
The average solution, last panel.
Here, no?
Yeah, here you can see it as well. Yeah.
Okay. Yes. Oh, sorry.
No.
No, wait.
Yeah.
I'm a bit
in the last.
Yes, exactly. In the inspect selection.
Here, okay. It's not too much. Being 30 data points was missing, or missing in the end. Yeah, it's not too much though. Yeah, I guess still, for me, it's still, you know, within the reasonable range, like for the missing points in the end. I won't worry too much, but if you really want to see what happened during that period, you can just try to select those points have low score between BC wood burning and your BBOA. Just select those points to see how the PMF looks like in the end. You can just summarize and averaging those solutions. It will be just like maybe 30 data points. Then you to see if it makes sense. You know what I mean?
Look at the errors or the residuals for those.
Yeah. But I mean, I won't worry too much about this. Yeah.
Okay.
But I won't worry too much about those because
you're right, probably
it's just 30 points, 30 data points. So
yes.
It's 30 data points is like Yeah, not too much.
I mean, regarding the
Okay, great.
regarding the BBOA contribution summer, I mean, I don't
No,
remember exactly. I mean, when we had this 6-7 years data analyzed seasonally, I mean, was then the BBA fraction in summer similar as now, or has something changed?
Can you go to slide 8? Maybe it's more obvious.
No, I mean in the...
Yeah, basically here. So for the spring and summer, you have higher BBOA contribution than the HOA.
Yeah, but was that the same in Yunyang's analysis, or was it different?
I didn't recheck. I didn't recheck. But I guess when I looked at the beginning, the correlations of my results with his was pretty good. So
yeah, I mean, I wouldn't be that worried. I mean, I think in Zurich we had similar results in the past, and I mean it actually coincides with COM14 data that we have. So I mean, when you look at COM14 of the EC, I mean, there is a significant fraction that is non-fossil, and yeah, I mean, as one knows, I mean, levodopa, for example, is to some degree volatile. So you lose a little bit of the fraction 60 in your mass spectra. I mean, the levodopa related part at least, and then, yeah, it seems like it should be lower if you would just probably look at mass 60 itself. But I think this is still not, in my opinion, I mean, or at least from our experience in Zurich, this still seemed reasonable when you took into account the black carbon. I mean, you cannot do the same in Sirta because there the carbon is contaminated by carbon-14. The carbon-14 is contaminated there due to the close bioreactor, so one cannot do the same exercise. But I wouldn't be worried. I mean, we'll still look a little bit if the criterion in the old paper by Monica Kripa was to say that I mean, if there is variability in 60 and in F60 in summer, that I mean also goes beyond just the kind of what you have in the background. That's a sign that I mean that wood burning is really also present in all the seasons. And then when this criterion was fulfilled, then we always said we either find one or we force one BBOA factor into the solution. So I don't know. I mean, I will assume this is all okay.
Okay.
So,
cool.
This is just how it is.
Can I make a comment or ask a question? Hi, this is Veronique. I'm sorry, I had a conference call before, so I was not able to join. Did you check the correlation with your BC wood burning for this BBOA in summer?
Yes, I mean for the whole period, but I couldn't use this criteria because it doesn't correlate that much in the summer.
I mean, BC wood burning in summer usually doesn't work well if the contribution of biomass burning is small.
And
yes, you can see that it doesn't. Yes.
And the second thing is, you have of course much more noise in summer on this MZ60, and is it a problem that we take the average uncertainty for the error matrix and not a variable? I remember there was this option that was discussed in Sophie, like you have this cell-wise uncertainty matrix, especially for seasonal masses like this, where you could have a really strong variable in wintertime, and it could be a weak variable in summertime. This may have been discussed already. I'm sorry.
No, but the uncertainties are taken for each point, right? But I mean, you mean the choice of downweighting?
Yes, because maybe if it's considered a strong variable, it really tries to fit these points. I mean, and you may just push it a bit too much, the BBOA factor.
I think the uncertainty is included. I mean, as a function of time, it's not constant, or I don't know. Ian is. I'm not aware of anything.
Yeah. So, Veronica, did you mean the way we downweight it? Like,
yes, I think now is the average is taken, but there was this cell-wise option.
It is. You still have this option, but I think there's something. I don't know. I mean, at least Francesco and Anna both suggest me to do it average-wise and not cell-wise. So, Anna, are you here? If you can make a comment.
Yes.
I'm not sure why.
I think it really depends on your data set. So, and how consistent your variables are over the year. But I don't know. I mean, I guess it depends really on the data set. I mean, you can try, but I think it's more like if you have like offline samples or so, it's probably more important to have the cell-wise than the average.
Okay.
Yeah, but like, is that true? That the Sophie still had the problem doing it cell-wise?
Not that I know of, but I also am like, yeah, I not that I know of, but.
Okay. Yeah, because I think previously I was told that the cell-wise option is not working properly somehow.
I think it's working properly now, at least for the people from offline. It was working properly from the data that I've seen.
I'm not sure it has been extensively tested.
No,
they see
not yet.
Anyway.
But I think so far we all recommend to use average so far.
Sorry, it could be interesting to see how much it influences the solution, especially when this BBOA is supposed to be low, and this data has obviously more uncertainty in summertime than in wintertime.
Yeah, I think
go ahead, Anna.
No, I just think, I mean, there are several options that I think were never really like extensively tested in Sophie, that people just typically take the standard option.
Yeah.
But I think the signal to noise of F60 is not very high. So I don't think it will drive a lot of the solution. I mean, sure, you kind of fix a profile eventually that contains, or it's nearly the only profile that you fix that contains 60. So you'll somehow pick it up, but still, I mean, there's very little Q in 60, I believe. I mean, compared to even in the biomass burning profile, I mean, there's much more in 29 or other ions, I will assume. So I don't see how that could be a problem. I think it was rather like that in Zurich. I mean, the fraction of 60 went down, but nevertheless, I mean, the contribution was not going that low. It was just the fraction going down a bit, but I mean, the other ions, or the total contribution still stayed significantly high, but that means the rest of the profile actually, I think, kept it high in a way. I mean, it was not all going proportional to 60. So I'm not sure. But yeah, I mean, always good to, I mean, if there are possibilities to test this, or I mean, sometimes interesting to actually upweight or downweight certain MZs to see what kind of difference it makes.
Laila, could you do this test? please? Maybe to try just for the summer and to see what's the difference between the average and the cell-wise downweighting.
Yes, yes.
Yeah, I think I just checked the Yunjiang's paper in 6 years. I think in average, it seems like the PBOA still, in the summer at least, still smaller. The contribution is still smaller than the HOA. But for the spring, it's like PBOA seems like still higher, a bit higher, but not for the summer. So I just checked.
Okay.
So maybe you need to, I don't know. Maybe you can there in the paper it's 6 year average, of course, but here I guess maybe you can do it. Just compare it with the year you have here. Maybe make more sense. So yeah. Okay, so I guess we should move on to the next speaker. Asana, please. Could you share your screen? So she will talk about data from Lily.
Lil.
Lil. Okay, my bad.
Lily sounds nice.
We cannot hear you yet, Asna. Can you hear me, Hasna?
Or we make a break or somebody else presents.
Yeah, maybe we can. Can Michael or Stefan?
Yeah, I can present.
Perfect. Okay, sounds good.
Okay. Give me 1 second, okay?
Sure, no problem.
Okay, I need to share the screen. You can see my presentation?
Yes.
Okay, cool. I'm putting it full screen. Okay, now do you see my presentation or do you see my other screen?
I think we are seeing the slide.
Looks good.
It's not zoomed in.
Everything's okay?
Yeah.
Just do the presentation mode.
Yeah.
Okay, so I will present results from Cyprus. So first, a few words about the site. We are in the far east side of Europe. Administratively, we belong to Europe, but geographically, we're in the Middle East. So we have pollution coming from Western Europe and Turkey. Also, pollution comes from the Middle East. But we also have impact from 2 desert areas, the Sahara Desert and Middle Eastern deserts. We have Mediterranean Sea on our west, and we have cleaner masses coming from there.
Michael, I think
Yes.
you're still on slide 1. I think your slides is not turning or something.
Really? Okay. You don't see it changing?
No.
You're not in the slideshow mode.
Yeah,
We should
slideshow mode, or maybe you have to share again.
Yeah, that's what I'm doing. Okay, let's take the other screen.
No, this is
Use
now
my
good.
laptop.
Now we see it.
Instead, maybe that will solve problems. Sorry. Okay.
Yeah, now it's
Now,
good.
do you see my slide too?
Yes.
No? Nothing
Yes.
changes?
No, it's fine. Well.
We can see your slide too now. It's good.
I cannot hear you. I cannot hear you anymore.
We cannot see your slides.
What's wrong?
Okay, seems like we have some technical issues.
Share screen, share my whole screen, share.
Yeah, now we can see the
I cannot
slide.
hear you anymore. Okay. I cannot hear you though. Okay, we can hear and see you. Okay, I will go on with the presentation, and I don't know about the questions. It will be tough, okay? So I will present Cyprus. We are in the eastern part of Europe. Administratively, we belong to Europe, but geographically in the Middle East. We're very close. We're in proximity to the dust belt, but outside of the dust belt. I'm guess a lot of people are familiar with that. What you're not maybe familiar with is that Cyprus, which is over here, I hope you can see my mouse. It has 4 power plants which are oil-based power plants, and there are a bunch. There is actually a front of power plants, coal, oil, and gas, especially to the east, but also to the northwest of the island. We have this map. It's a NO2 satellite map, so it's columnar NO2, and we have identified here hotspots of NO2, which basically match the power plants in Cyprus. Also, you can see some cities. I have noted down the capacity of these power plants, and what you need to keep in mind is that the island is divided in half. So the ones in the north, even though the capacity is relatively low, let's say to the one which is 868 megawatts capacity, they produce more NO2. And this is very hard to explain in terms of fuel quality. It can rather be explained in engine quality and how well it is maintained. Now, moving on to the site, this is the seasonal composition observed at the site, and the time frame that we will discuss, the time period, will be from March 2015 till mid-January 2017. One striking feature is that in the Eastern Mediterranean, there is a site you're mostly familiar with, Finokalia, and there the dominant component sulfate is around 50% of PM1, while here the dominant component are organics. Another feat also within the time period, I need to note that there is a wildfire event which lasted 3 days, and we will evaluate it as something special and different. What I would like you to keep in mind is that both sulfate and organics, they maximize during summer. And also, as I mentioned, that the organics dominate. Now, where all these things come from, or can we identify the source region of them? So for sulfate, which is the middle graph, this is a PSCF analysis based on high split trajectories. You see that the source region is basically Greece and northeast Europe. Or East Europe, while for the organics is the Middle East, also for black carbon. Now, I have presented these results before. And you can see the average profiles for this 2-year period regarding seasonal and rolling for different windows, 7-day, 14-day, and 28-day. What I would like you to keep in mind is that the more oxidized and the less oxidized OA are persistent throughout the 2-year period. The site is a remote site at the side of at the foothills of the highest mountain of Cyprus, which is called Rhodos. And also this mountain is forested, so we're basically inside the edge of a forested area. So this is a remote site, so it makes sense that we have these secondary factors present throughout the 2-year period. But we also have this HOA, which is also present only 2 months we couldn't identify out of these 2 years. So it's almost always there. And then we have some biomass burning factor coming out sporadically. In the seasonal, it only came out in 2016, in the winter time of 2016. However, in the rolling, in all of the rolling, regardless of the window, it came out during also autumn and winter of 2016. So what I would like to focus now is this HOA factor. And what is weird with this HOA factor is this 55 to 57 ratio, or 57 to 55 ratio, F55 to 57. So it looks like this, and it's consistent on whatever method I have applied. I would like to remind you how I came up with this HOA. So first of all, it is persistent, almost persistent throughout this 2-year period. It is deconvoluted in unconstrained runs. So if I run unconstrained with three factors, this is my third factor. In order to identify it better, I did not use unconstrained runs, but instead I used the Megapoli HOA as a constraint, but used a very, very high A value. Typically to the high end, right, to 0.7, to an A value of 0.7. And when I did that, my secondary factors, the correlation with nitrate and sulfate, improved. Now, as I mentioned, the 55 to 57 ratio is 0.55. But for COA, for instance, for the cooking factor, you get something like 0.4 in literature. And for HOA, you get something like 1 unity. So this is more or less, it makes it a bit distinct from these two. Now, this is not, of course, an evidence that there is something going on here. But also, I'm lacking a diurnal profile for this factor. There is no distinct diurnal profile. So this also tells me that this probably what I'm looking at is not COA. Also, if you look at the time series, you will see these spikes. You can see them here. This is because the site is co-located with a forestry department. So there are some civil servants working there, and they come with their cars. And basically, this spike, what you see is vehicular HOAs, these people coming with their cars to the site. But they come at specific times. They don't move around. It's not a busy road. Also, these people leave, and during the night, there is no one there. Really no one. So my PMF shows that there is a persistent HOA even during nighttime. And I've tried to see if this happens by excluding daytime, and this HOA comes out. Okay. Another, I will also show that this is not a local source in the next slides. And I will also show that the correlation of this HOA factor with my external, which is BC fossil fuel, is strongly seasonal. So these are the interesting things about this HOA factor. What I did, I dug into the Jimenez archive and tried to correlate all of the factors that I got with this archive. So I've distinguished 5. The 4 factors I mentioned, more oxidized, less oxidized OA, HOA, BBOA, and separately the wildfire event. I will not go into many details. I will focus on the HOA. So there is a good correlation with several COA factors from this archive, and this makes sense. However, as I said, there is no diurnal pattern. We're not in a city. We're in a remote area, inside basically the edge of a forest. The other striking feature is that we get a very good correlation with a diesel exhaust from this paper from Seys et al. In 2008. In specific, you will see a lot of, there's several factors that match from this paper that match the one I'm talking about. This one in specific is a diesel truck engine that flushed the chamber immediately without any further oxidation. So this is like really fresh diesel exhaust. While after 5 hours of oxidizing, you get something like this. So my HOA is in blue, and the one I'm referencing from the paper is in orange. And if it's not 5 hours after, it looks a bit different. But in either cases, this 55 to 57 ratio is there. So it's different from this typical vehicular HOA. So this is the 2 hour in the chamber profile in orange, and mine in blue is constant. Of course, there are only 2 more that in this archive that refer to diesel. I'm only showing one. The other is more or less the same, and they're not supporting that this is a diesel engine. So basically, this is a bit puzzling to me. In this case, the one I'm showing on the the bottom right, sorry, in the bottom right is a study where they went behind, with an AMS, they went behind public transportation in New York, and they used diesel, okay? So one is a chamber study, the other basically sort of an ambient study. Now, where does this HOA come from? According to our PSEF analysis, it comes from the Middle East, where we have seen also a lot of BC coming from there. Also, if we do a pollution rose, we see that mostly our concentrations come from the East. And as I mentioned, what is very interesting is that our correlation of HOA with our external, which is BCFF, has a strong seasonal, very strong seasonal variation. And this is consistent regardless of the window I applied. So what happened is that during summer, basically, my R square is 0. So I cannot apply a P10 in this case. Instead, what I did, and also in the seasonal runs, is I made an unconstrained runs, even in rolling. And I tried to identify whether there is an HOA coming out. And if it did, I said, okay, now I'm convinced that there is an HOA out there. And I just have to define it a bit by adding some constraints, but it's there. Also, there are these power plants that produce NOx, and I'm heavily convinced that this HOA is influenced by these power plants. And these power plants, they produce NO2, as I showed in the satellite, and as a result, my factors, they correlate quite well with PM1 nitrate. Now, that's not surprising to me, but if I apply a t-test, then it will be a problem. And basically, in this case, if I apply the t-test, all of my time period, it's ruled out. So instead, this is the criteria I've used. I've used the P10 in all the factors except the HOA, and some additional, which you can see on the bottom. And to identify whether a factor is HOA, more oxidized, or less oxidized OA, or BBOA, I did a spectral similarity with using the dot product. These are also results I have shown in the past. Basically, it's how the seasonal results compare to the rolling results for 7, 14, and 28-day windows. There are some discrepancies, but basically there when, for instance, in winter 2016, in the seasonal I cannot identify a BBOA event, while in the rolling I can. So this is why the profiles don't match very well, while in the rest, they're quite good. Also, in the time series, the match sometimes is not very well, and this is because the trend is the same. They go up and down together, But sometimes the ratio changes. So basically when you, for this specific time period, you get basically two lines and the correlation is no longer, the correlation coefficient is no longer that close to unity. And I have checked each and every one of these. So this is the temporal variability of my factors for the seasonal. And my favorite rolling is 14 days. So I'm showing only this. And you can see the big difference here is the BBOA, which is spread through winter 2015, which could not be identified in the seasonal. Now, I've shown the HOA and the PSCF analysis on that, but what about the secondary? And they are consistent that they come from Turkey and basically Greece, both of them. Now, a very interesting, as far as I'm concerned, finding, let's say, of these low oxidized OA is that the diurnal pattern changes with season. So during the hot months, which is spring and summer in Cyprus, you get a second peak. Again, I would like to note that my site is at the foothills of a forest. I think you can see it in this map over here, okay? This is our site. So during the hot months, you get a second peak from at 9 UTC, which is 12 local time. So basically midday, okay? And it is highly likely, and I need to check this further, it seems that this is the oxidation of biogenic emissions. And then there is a nighttime peak, which is at 9 UTC, 8, 9 UTC, which is 11 to midnight, basically. Another interesting feature of this low oxidized OA is the 44 to 43 ratio. So during 2016, there is a clear seasonal pattern, which peaks during summer, and this is also what I would expect. However, you get the more or less the exact opposite, not the exact opposite, but not very clear pattern in 2015, and it definitely doesn't match the 2016 one. So this one remains unclear to me. And with this, I would like to conclude and take your questions, but you have to give me some time to fix the problem because I cannot hear you. I'm stopping to share my screen. I'm trying to fix a bit my... Can
you hear me now, Michael?
I only have one option for a microphone. Speakers, assistant. Okay, can you hear me?
Yes.
I cannot
hear me. No?
The only problem... Yeah, you can hear me, but I cannot hear you. That's the problem. Like,
So let's just type your questions in the...
Yes, I can hear you. I can hear you.
Okay.
I was asking maybe if... now he hears us.
Yes, I can hear you. Yes,
Oh,
fine.
okay.
Great. Sorry. I really don't know
so
what...
you can... Yeah, all right. Can you just answer James' question first in the chat? He mentioned
this is
something.
just hypothetical. You mentioned you're in a forest. So could the summer HOA be influenced by plant waxes somehow?
Yeah, that will be also my question. Is this a power plant oil combustion or coal combustion power plant?
I tried to identify an I epoxy factor, but with a QACSM, sorry, it was impossible. And I don't think a lot of people have, I think it was a bit far-fetched from my side. The answer is yes, this is also possible that it could be that in the summer, the plants have an influence.
I mean, just a bit of context. I mean, people have using GCMS, people have reported plant waxes in particulates before in forests, although I don't exactly know how they get into the particles, whether it's like mechanical or like volatilization and condensation or whatever. And I don't actually know whether it's likely to be significant or not, but this was a worry for a while, like ages ago. We've not seen it elsewhere, but I'm just wondering whether it's something to do with your specific location where it might be. Because I mean, I would have thought if it was combustion related, it should have correlated with, you know, black carbon, and that seasonal thing is just striking. I don't know. It's just a thought from like years ago.
I will answer your question with an extra slide that I have. I'm going to share my screen again, and I'm a bit afraid of that because I lost sound when I did that, but I will do it again, okay? Okay, can you see my screen?
Yes.
Okay, and I can hear you, great. So one of the features of this site is that the air mass origin is very seasonal dependent. During summer, you get northerly winds. They're called the Etesians. They come every year, they're very strong. 80% of the air masses during summer, they come from the north. However, and during, for instance, autumn, you get air masses from the Middle East. In autumn, they're like 30%. One of the 3 times you're going to check the air mass origin, you will get from the Middle East. The other 2 out of 3 could be something else. Now look at this HOA. This is on the left is the annual. On the right is the seasonal. If this was local, I would expect a hotspot in the island. I don't get that for most of the seasons. And for the hot season, I get it up from the north. So there is nothing at this stage to suggest that the HOA at least is local.
I mean, you had a few peaks, right? I mean, very short.
The cars, you mean? These?
Are you sure they're cars? I mean, could it also be chainsaw or something?
You're talking about this, right?
Yeah.
These are cars, and I know it because these are public servants. They come at specific times, they leave at specific times, and I've checked these peaks and they match. They never happen during daytime, for instance.
Do they influence your solution if you would take them away?
I have the most striking ones, because sometimes they will stop with their car with their engine open next to my next to my station. This I've removed, yes. But what you see is when you check the organics, for instance, it's not apparent. If this is what you're asking. So you have to do the PMF to say, yeah, okay, this is what this is. And if I do that, because they're there all 7 days a week, because these people, they're also the fire brigade because of the forest. They're there, so they're coming there also during weekends. You will get a lot of data expelled.
I'm just thinking, do you think your HOA profile is driven by these small events or not?
That I don't know.
That's why I would try to exclude them, if that's possible somehow. Short-term variation. But I don't know. I mean, the high 55, 57 could also come. I mean, if it's still partially the. I mean, if one still would think about a little bit about the hypothesis that it's from the power plants. I mean, we saw once in data in, I think it was Lithuania. Is that right? I think Lithuania. Yeah. I mean, in wintertime, they had to turn on somehow a heavy fuel oil kind of electricity plant or something because I don't know, that they didn't have enough power. And then we got this, I mean, HOA-like thing, but it looked really different. It was more unsaturated. It was more 55 to 57. But still, I mean, I guess it doesn't look like I mean, a lot of it is really super local at the end. So it's probably just a bit aged.
And also, we are doing now the same job in Nicosia, which is 40 kilometers away, but much closer to this power plant. So, for instance, Nicosia, can you see? Well, actually, Nicosia is here, just below this power plant of 362 megawatts, just south of it, which is downwind. And we identify a similar factor. And yeah, the problem of these with these factories is that basically the north of Cyprus is no man's land. There is they're not a country. They don't have any relations to other countries. They're not recognized by the only but two countries, Turkey and Azerbaijan. They're no man's land, and they are very vague. They're very unclear. They're not transparent in what they're doing. It's very hard to find information about the power plants, for instance. Not only that they are in Turkish, but they don't give data. We've asked through local people as well, so it's very untransparent on what's going on there.
Yeah, okay. Michael, can you explain more about why the t-test is not working?
So, because this is from the seasonal solution, it also applies to the rolling. So this is the correlation of nitrate from the ACSM with my deconvoluted factors. These are my seasons on the x-axis. And as you can see, the correlation of the three factors, the more oxidized, the less oxidized, and the HOA, with nitrate, they're very close to each other. So if you apply the t-test, it fails.
Yeah, I mean, there's two options in the SOFI, like either one type of t-test is doing compare with other factors, like what you have done right here. The other option is just to see if, for example, here your nitrate and LO, are they actually correlate, for example. But I will not recommend you to do the t-test for the LO and MO. I will just take all after sorting. Just make sure the 44 in the MO is larger than 0, and if 43 in LO is larger than 0. That's it. For
this
LO
is already.
MO, this is here. Not, yeah, I know, but like because we kind of also provide a criterion list in the protocol. So, and we also find that the criteria can change your LO and MO solution in the solution significantly. So I will still prefer you follow the criteria, follow the protocol.
I am.
Yeah.
I am. Actually, the only time I haven't followed the protocol is the HOA, because because of the
HOA. I'm happy. I'm happy about it. But for the MO and LO, I think the previous protocol, yes, it's using the 10th percentile, but we have updated. We recommend to use the t-test. I mean, yes, here. I mean, no.
Should be done by
but the MO and L
44.
are not t-tested. We just take all. We just usually, we are not using even the ratio to sort it. We're just using the 44 from the MO to sort it. This is the updated protocol. We have discussed this quite a bit about the criteria for the MO and LO to reposition these two unconstrained PMF factors. So, I mean, well, it'd be great you can still follow the protocol regarding this, because it will change your solution quite a bit. like the way you're sorting it, the difference between the ratio, you sort it based on the 44-43 ratio and just 44, that will change your solution as well.
If the identification of the factor, whether it's MO or LO, it's done by this, the one in the dashed line, and if the F44 to F43 in the LO, in the LO is higher than the one in the MO, then I reject the solution.
Yeah,
That's
I know, but
basically what it's trying to say.
that's I know it makes sense, but the thing is, I still, well, because that's one we still wanted to do it like consistently between different places, so I will still recommend you to do so. Yeah, I mean, yeah, of course you can do this in the paper. You if you want, I mean, you can. I'm sure you want to publish this work as well by yourself for this whole data set, so you can do that. But if you, I mean, for the overview, I will still recommend you to do it by following the protocol, because this criteria list I will also provide it in the paper. If you don't follow this criteria, it doesn't make sense.
Okay.
Yeah. So
I think I should contact
understand.
you to refine this. Okay.
Yeah, sure. And yeah, for the HOA factor, as you mentioned, is not just in your case, the 55 is larger than 57. I think in Costas, in Czech, this remote area, they also, when they did the unconstrained PMF, they have shown distinct morning rush hour and the evening rush hour. This HOA factor has higher 55. So I think it's for your HOA. I'm convinced right here. I'm just maybe will be good if you can identify this power plant if it's oil or coal, but maybe it's not possible because I think in Ireland the oil heating factor it's HOA like. So maybe you can somehow identify the source of this oil, if it's oil, power plant, right? So
I've already done that job. The ones in Cyprus are oil-based power plants.
Okay.
So you see this picture? Maybe I blow it up a bit. So the yellow ones are oil, and this is Cyprus. Can you see my mouse?
Yeah.
Okay, so this is Cyprus, and these are oil power plants.
I see. Or maybe another, I think in Ireland it's the oil heating. It's not the power plant, but it's oil heating factor. It's also look quite alike with the HOA. So that you can also think about. Yeah, just let you know.
Yes, from the seasonality, which is over here.
Yeah, I mean,
it doesn't say anything about. Actually, I have the HOA. It doesn't pop out in the winter. It's the same throughout the seasons, more or less. That's why heating didn't come into my mind. We do use heating. We do use oil for heating. That's true.
Can you answer maybe last question, and after this question we have to finish because we have to come back at 1:20.
Yeah, okay.
So maybe you answer James' question. Would an oil power plant not also emit black carbon?
Yes, it does. Of course it does.
Yeah. Okay. James, are you happy with the answer?
Yeah, I mean, I'm still obsessing over the lack of correlation with black carbon with the HOA, basically. So
in the summer.
Okay.
Well, in the summer. So in my mind, the oil power plants wouldn't explain that one. But
Okay.
Depends on how fast the HOA will oxidize.
No, my point is that if the HOA in the summer is not associated with black carbon, then it implies it's not got a common source. I mean, that the R squared going down to 0 is really quite striking, in my opinion.
Yeah, well, okay. One thing, yes. During summer, not for so long periods, but actually, let me show you.
Can you, sorry, I have to stop you right here.
Okay.
Can you guys maybe
Anyway, all my factors during
discuss in
summer,
offline?
the correlation goes to 0. My more oxidized with sulfate goes to 0. My less oxidized with nitrate goes to 0 during summer, both summers. It's not just the HOA. Everything goes to 0.
All right.
Okay.
Sorry, I have to interrupt.
Okay.
Because
Yeah.
otherwise people don't have
sharing.
time to have lunch. Yeah.
Okay.
Okay. So, schedule. Let's just come back at 1:20 Zurich time. Then we can start with Hasna. Yeah. Thank you very much, and see you guys later.
See you later.
Yeah.
I'm not convinced by it, but it's primo factor again is primary diesel resource. And there are no diesels around. Yeah. Yeah, they don't go out at all. You see the spikes, they're not great. They're too small. There are no big roads, easy roads to get there. There's system. Running throughout the year, this is not Beirut. If I wasn't Beirut, I would think about it. Yeah, there's someone doesn't have electricity and you use it, you're sure they're going to track it down. It doesn't show their own space.
This is the.
Will
you say?
Yes.
You're not going to have it.
No, but I don't have it. Bring whatever you say.
Smile. How does it feel?
Hello, everyone.
Hello.
Hi.
Hello, welcome back. Hasna, would you be able to share your screen, please? No? Hasna, can you hear me? No? Okay, I think Hasna still cannot connect at the moment. Stefan, would you like to share your screen first? Would you start first then?
I can do, just hang on for one moment.
Sure.
Share screen, I'm pushing the button. Platt Birkenes. So I can share that presentation now.
Yes.
And then if I go on to slideshow from beginning. Sorry, I actually don't use Zoom very often.
Yeah.
Okay, and you can see the start screen
perfect.
now. Okay, that's good. Okay, good afternoon, everyone. It's nice to see and hear everyone is doing well. For those of you who don't know me, my name is Stephen Platt, and I work as a scientist at NILU in Norway. This afternoon, I'm going to talk about source apportionment of ACSM data at Birkenes from 2016 to 2018. Okay, so here you see a nice helicopter, picture taken from a helicopter of the Birkenes site. And on the inside panel here, you see the location of the observatory, which is in the south of Norway, quite near to the coast. And it's a regional clean, as you can see from the picture, and somewhat maritime site, but it does receive episodes from Eastern Europe. The site has seen a recent expansion of online measurements. For example, we've now installed the QACSM since 2016, which is the data I'm going to present today. Ethylometer since November 2017, and other online instrumentation via Actris and ICOS. And the site actually has the longest carbonaceous aerosol filter time series together with tracers. So we've got carbonaceous aerosol since 2001 and lead-glucosan and more since 2008. And from the analysis of these data in publications actually gone online today, we do expect to see some fossil fuel and biomass burning in the fine fraction of OC. This is especially in winter. So here you see my very first attempt at doing PMF from the Birkenes site. And this is kind of the status of the data that we had for a long time before I was inspired to look at it again as part of this colossal and project and Ian's paper. So what you see when running unconstrained PMF on Birkenes is quite typically that the single masses drop out as factors on their own. And this clearly it shows that it does not work for either 2 or 3 factors, and presented here are averages of 20 runs. So the reason why we get these single mass dropouts and why we don't get reasonable data is obviously the low concentration. So it's quite a clean site, and it turns out that most of the data is in fact down-weighted, with very few masses not considered weak. So the way to get around this is that I have averaged the data to as much as 4 hours, and also reduced the weak threshold to 1.8 from 2. So I would say a value of 2 is probably a little bit arbitrary, and 1.8 is basically the same as 2. And doing this brings an additional 10 MZs into that aren't down-weighted as an average. So doing that and running a 3-factor solution, constraining only the HOA, we see what drops out as a reasonable-ish looking BBOA factor in the factor 2 shown here. And I should say that I didn't only investigate a 3-factor solution. I looked at lower and higher orders. This was the most reasonable looking, also as indicated by the drop in QQ expected. However, you might notice that there's a lack of MZ43, which of course, although we expect an aged aerosol, is not a reasonable solution in this sense. So to move on from that, I constrained actually to the NG BBOA average profile. And here's, you see the solution, the 3-factor solution that I get out when constraining HOA and BBOA and running a bootstrap. And one criteria I applied to this wintertime solution was to check the P value for correlations to an external HOA time series. And so the P score should be lower for HOA and ethylometer PMF factor 1, which I'll present in the next slide, than for any other combination. So it should be a lower P score than the correlation with factor 2, and it should also be a lower P score than the BBOA correlation with the PMF factor 1 from the ethylometer. And this leaves 194 runs for the average, which are shown here. Then the correlation to the external factors was a correlation to a fossil and biomass factors, which I actually got from performing PMF on ethylometer data. And these data are in prep or actually published online today in Utri et al. And so here you see the correlation score versus the alpha value used in the bootstrap, and the correlation of the biomass burning to the external PMF derived EBC-BB was around 0.8. The HOA correlation somewhat lower, but these were both actually higher than you would get from correlating to an external ethylometer model, EBC-BB and EBC-FF, which is also quite nice for my other work that I'm doing on that. So despite the low correlation of the HOA, I did check that there was at least significance according to the t-test. So the null hypothesis of no correlation was rejected. And we also see that across all the different alpha values, the R-squared correlations are quite stable. So it does look as though the solution is rather stable. And then moving on to the summer season, I first constrained an HOA and ran a 3-factor solution again, and you get what apparently looks like 2 OOA factors, which would be these two. And they did actually match OOA1 and OOA2 profiles quite well, but when you correlate these 2 factors together, you see that the correlation is extremely high. And so based on this, plus not least the additional complicating factors it would mean when trying to do rolling, of course, decided to reject this solution and instead found a 3-factor solution when constraining to the HOA and BBOA profiles from the winter experiment. The only problem here is that we do have very few points for comparison to external data. So I don't actually have a good time series to compare to. So the ethylometer data starts in November 2017. So that leaves only summer 2018. And unfortunately, there are some gaps in the ASSM data at that point. So far, I didn't find a reliable external series to compare. And then the bootstrapped version of the previous profile is still quite reasonable with respect to the BBOA fraction. It's quite a low fraction and still a rather sort of 8 to 10%, regardless of what alpha value you use. So conforming to expectations. Just to compare briefly the summer and the winter, I think this is what you would expect to see in a lot of ways. I note that the BBOA fraction does tend to be a bit higher than the HOA, but nevertheless, the primary fraction much higher in winter, much lower in summer, and even if in both cases OOA dominates. Then to conclude, I have presented 3-factor solutions for Birkenes in summer and winter. OOA is the dominant fraction with significant HOA and BBOA in winter, somewhat lower than in summer. Somewhat lower in summer, I should say. And I still need to do the rolling PMF, but we have demonstrated a reasonable seasonal solution as a basis. And I want to say many thanks to Ian for his input over the last few days. We've been sending a lot of emails back and forward as I try to look at this data. Okay, that was me. Thank you very much.
Thank you very much, Stefan. Can you go to your slide 11?
11, yeah.
Yeah, so here you said you don't have many, external data to validate your BBOA.
Yeah, indeed, yeah.
Yeah, so do you think, so what we have tried is to use the explain variation of 60, for example.
I didn't quite hear that, sorry.
The explain variation of 60 by BBOA.
I was just going to note that down on my computer, but now, of course, I leave the screen. Okay, so explain variation of BBOA. Yeah.
Yeah, of 60 by BBOA, actually, the how much BBOA will explain the variation of 60. That's there's a variable.
Yeah.
You can monitor it, and to make sure the BBOA explain most of 60 variations. There's a that could be done in the SOPHI by doing the t-test as well.
Yeah. Yeah.
And
as an initial guess, I mean, don't you think if all of the, basically almost all of the 60 is in the BBOA, yeah?
Yeah, I think so. So,
yeah.
but like,
but I will.
It will be one justification.
Yeah.
I think most of the time will be fine. And it can be some.
Yeah.
I mean, if you then do the rolling, you have to see if it stays like this.
Yeah, I should say the one external thing I do have to correlate to is a 3-wavelength PSAP, but it's not. So it's not a great separation of the wavelengths, right? We have 470 to 660. And when I've done some checks on that, and the HOA correlates reasonably, the BBOA correlates probably more than you would get like just by chance, but I'm not sure how well it should correlate like on general principle anyway.
But you had the ethylometer, no? Or not for the whole time?
Yeah, no, so it's the ethylometer started in November 2017. So we have one summer, and then I have some gaps in 2018 in the ACSM data. So it leaves very little, actually, unfortunately.
Veronica has a question. So
yeah, Stefan, do you have, you mentioned you were having levoglucosan on filters. Do you have like this daily resolution, or is it?
No, this is weekly. Okay. Yeah, so it's not so good because then you have, yeah, it should in principle give 36.
Yeah, but at least you could compare the levels that you get between summer and winter.
Yeah, I can compare the levels. I think that's probably a reasonable approach. Again, you've got to assume some kind of, yeah, there's a lot of assumptions, right? Because you would have to assume some kind of constant levoglucosan, BBOA, or OC ratio, you know, through the whole year. Yeah. But yeah, I think a little bit more work can be done to do an external comparison on that.
Yeah. Also, maybe also another thing might need to be done is, I'm sure you have done already, I think, to compare this 3-factor solution with a 2-factor solution without a BBOA, to see what you have gained by doing so.
Yeah, so I mean, I've obviously got the QQ expected variation, which would justify this, I would say. Another thing I have looked at, we can do all this on email later, of course, but another thing I've looked at is how well, for example, the factors all correlate with each other to make sure there's some appreciable difference, you know. In a sense, I don't see a lot of choice if we want to run a rolling PMF, because I mean, this is a fairly reasonable solution, I would say, even if we struggle to find external data, that we can, I mean, this is based on a constraint of the winter profile, right? So if we're going to run a rolling PMF, we pretty much need to go in that direction, I would say.
Yes, certainly. Does anyone question still?
This slide is unconstrained for the BBA.
Where are we on now? Unfortunately, it looks like I've done something wrong in the plotting. No, that's constraint. It's a constraint of only 0.4. So I mean, so in the bootstrapping, we're constraining. Or was instructed to constrain between 0 and 0.5, right? And
yeah.
here I just presented the factor solution that gives kind of the lowest contribution of BBOA in summer.
Yeah, I mean this appreciable 44 in the BBOA, which is maybe a bit high.
Mm.
But, yeah, I don't know. I mean, you're using the same as in winter there?
Yeah, this is the same constraint as in winter. But I mean, so it's perfectly possible to constrain lower. If I go to this slide, you'll see that actually, yeah, it's not so sensitive to the alpha value I put on the, you know, you're still going to get the same sort of conclusion, right? That it's kind of somewhere just below around 10% BBOA in summer.
Yeah.
One thing I do wonder is whether,
but maybe you should limit it a bit more.
Yes, I can do so. I think it shouldn't change too much in that sense, and that you would get a more reasonable factor profile.
Yes.
One thing I wonder is whether there's quite a lot of PBAP at the Birkenes site, and I do wonder whether any of that leaches into this kind of fine size fraction, whether that can influence, increase the BBOA fraction a little bit, but I don't see a way to really.
You removed it or not?
Removed what now?
You said the 44 fraction or the Pieper effect, no?
No, Pieper effect. No, I said that there might be quite a lot of PBAP. We've seen that on the filter data.
So
it's potentially
no,
influencing.
I don't think you see that. I mean, there's a PM1 inlet, right?
No, it's isn't it a PM2.5, the largest available lens? I believe it's the largest lens. It's 2.5.
Okay. Yeah, then
it is. Yeah.
Okay. I mean, usually we see. I mean, when we did the offline, we saw a little bit in 61. I mean, you could check if there's any signal in summer for 61.
Yeah. Okay. I think it's probably not an issue, but it's just
probably not.
Was at the back of my mind.
Yeah, sure. But it looks pretty good, actually.
Yeah, I mean, it's quite a simple output, but a lot of it's quite a tricky data set just because of a lot of noise. You know,
you needed the averaging. So.
Yeah, for sure. Yeah.
Okay, shall we move on? If nobody has a comment.
So I stop the sharing.
Okay, thanks, Stefan. And Hasna?
Yes.
Can you start to share?
Yes, could you hear me right now?
Yes.
Yes, good. Sorry for the technical problems.
No problem.
Okay.
Good. Now we're seeing Sophie.
Okay. You can see also my screen?
Yes.
Okay, good.
Perfect.
So I can begin. So hi everyone. I am Hasna Shibeshab. I am a PhD student at EMT Dubai in collaboration with NRS. My thesis is directed by Véronique Reffaut and supervised by Olivier Favez and Joël Breto. So during my thesis, I will apply PMF on ACSM data for different French sites. So today I would like to present you the seasonal results of data of Lille. So first of all, I will begin with site descriptions, which is an urban background site located in the University of Lille campus, and we have the SSM measurements and that are operational until now. But for this study, I worked for the period from October 2016 to August 2017. Here I will present the time series of concentrations of different species that we have in our site. So as we say in the graph in the left, we have some pollution events that exceed 120 microgram per cubic meter. And as we can see in the pay charts of 2016 and 2017, we have a high contribution of organic with approximately 40%, followed by nitrate with 34%, and we have for ammonium 14% and sulfite with approximately 10%. In this slide, I will present some characteristics of my seasonal PMF. In this table, I present the 4 seasons. Spring with 3 months, March, April, and May. Summer with June, July, and August. Autumn, September, October, November, and winter, December, January, February. And also I present the number of observations for each season. As we say, during the winter we have a higher number of observation, 3,425, and the latest one is for autumn, where I have 1,631 observations. My base case based on 2 to 5 factors for each season, and we apply PMF with MZ up to 100, and we removed MZ 12. I will begin with the winter results. Here I present, here as you can see, we have 4 fractures, 2 constrained primary POA, which is HOA and BBOA. I constrained the first one HOA with the factor of from CRIPA with random value 0.3 and a step of 0.1, and also I constrained the BBOA with the profile from inches with a random value 0.5 and U delta of 0.1. And as we say, on the left, we have the mass spectra of H factor. The first one is HOA. And as we say on the right, their time series, the HOA has different peaks in terms of time series. The second one is BBOA. And as we say, it has specific peaks in terms of time series. The third one is MOOA, which has a strong peak on MZ44 and a large variability in terms of time series. And the last one is LOOA, which has a lower variability in comparison with the MOOA. And as we say here, they are correlated with the peak like BBOA. Here I present the daily cycle on the left and the weekly cycle on the right for H factors. As we say for HOA, we have 2 peaks, one on the morning and the other on the evening, and it's higher during the working days. For BBOA, we have a strong peak on the evening and also a higher variation in and also a peak in weekends as we inspect. For MOA, it has a stable variation for the daily and also for weekly cycle. For LOA, it has a peak on the evening. It seems like the BBOA. And in this slide, I present the contributions of each factor. As we say, MOA has a higher contributions, 46%, followed by LOA, which has 22%, and for BBOA with 21%, and the last one HOA with approximately 10%. On the right, I present the correlations between factors and their tracers. As we see here, good correlations between HOA and base fossil fuel, and also a good correlations between BBOA and base wood burning. We have also correlation between MOA and sulfate and LOA with nitrate. So after that, I apply the bootstrap on the result with a random e-value 0.5, and I use some criteria on the HOA and the POA based on correlations with base fossil fuel and base wood burning, and also a criteria on BBOA with p-value below to 0.05 for exponent variations of 60 variable, and also some criteria to sort MO more oxidized and less oxidized OOA based on F44 and F43, and not allowing this variable being 0. So here we have the results of winter bootstrap. I present on the left the mass spectra of each factor, and on the right hand the daily cycle of each factor. As we say, the HOI with 2 peaks, BOI with a strong nighttime peak, and for MOA stable variations, and LOA, as we see here, we have also a small peak. I don't know, we can see near this one, we have a small peak of 60. It seems it has the variation, same variations like as BBOA.
Just a quick question: Did you sort? How did you sort the OAs?
Yes, but I already have this.
No, sure, that's fine. But how did you do the sorting of the OAs? Did you do it by 44?
Yes, 44.
Okay.
Here I present the time series of each factor on the left for HOA and BBOA, and the large variation of MOA, as we say, and low variation of LOA, and on the other side the weekly variations. Here I present the contributions of each factor for the winter bootstrap result. As we say, the HOA has almost 10%, BBOA 23%, and the higher one for MOOA with 41%, and 24% for LOOA. On the right, we have the correlations. So good correlations between factors and the external base, say, fossil fuel and wood burning for HOA and BBOA, and also for there are you can say here like green correlations between MOA and sulfate and sulfate and LOA and nitrate. Right now I will present. I don't know if I can present all the seasons, Ian, or what do you
maybe
think?
do it faster. You don't need to explain all the details. Just showing plot.
Okay. Okay.
Just go doing faster then.
Okay.
No.
So here for summer, we have also cut 4 factors, but in fact, we expect just to have 3 factors in summer because as I said at the beginning, we are in university campus, so we don't expect have a BBI in the summer. But in order to apply RONIP MF on the whole year, we constrain the BBA with NGs with a random e-value 0.5 and a step of 0.1. But as we say in time series of BBOA, it's we have episodic events, different episodic events, and also it's attached to 0. So you can say it's linked to noise, maybe. So we have the mass picture of the 4 factors. Here, as we see also for the weekly cycle for the factors for BBOA, it's higher in the working days, so it's maybe strange. For the others, we present here their daily cycle also. The contributions, we have high contributions also for this BBOA. It's approximately 14%, but when we look for the correlations, there is no significant correlations for BBOA. As we say here, there is a correlation between BBOA and BC fossil fuel, which we can say that the HOA and BBOA are mixed. So we don't know. After that, I apply the bootstrap on summer result with the same criteria, and I obtain this result of here I present the mass picture of each factor. Here we have the MOA, which with a large with a strong peaks on 44, and here we have the 43 and 44 for the LOA, and here I present their daily cycle avec with 2 peaks of HOA, 1 peaks, 1 strong peaks on the evening for BOA, and so on. Here I present the time series of this result. As we see, also for BBOA, it's attached to 0. And here I present the contributions of each factors. The HOA is almost always we have this approximately 10%. Here BBOA is 15%. Here we have the correlations as as I said before, a good correlation between HOA and BC fossil fuel, but for BBOA, it's not very clear. For spring, for spring and autumn, I constrained the HOA and BBOA with HOA with the profile of from CRIPA with random e-value 0.3 and a step of 0.1. For the BBOA, I constrained with my own BBOA of winter with a random e-value from 0 to 0.5 and a step of 0.1. And also I constrained the variable 43 with 0.05 for HOA and BBOA because I have some problems on this variable for the oxygenated profile. So here, as we say on the left, you have this picture, the mass spectra of the four fractures, and on the right hand, the time series, HOA, BBOA, and a strong 44 for MOA and LOA. Here the daily cycle with 2 peaks of each HOA, a strong peaks for BBOA, and a stable variation for MOA and LOA. Here the correlations, here there is a good correlation between BBOA and BC with Bornene, approximately 0.6, and a good correlation between HOA and BC fossil fuel. For the contributions, HOA it's almost 10%, BBOA 13%, and a higher one for the MOA. And after I apply the bootstrap on spring result with random e-value 0.5, and I apply some criteria on HOA and BBOA, and also to certain MOA. So I represent the mass spectra of each factor, HOA and BBOA constraint, and the two unconstrained factors, the MOA with strong MZ44 and the LOA with 43 and 44. I represent the time series on the left and the daily cycle on the other hand for each factor. And as almost the HOA has a contributions of 10%, BBOA with 14%, and the higher one for MOA with 15%. And the correlations, we can see here good correlation between BBOA and BC wood burning, also between HOA and BC fossil fuel, and LOA and nitrate, and between MOA and sulfate. Here I present next the result of autumn. Also, as I said, they constrained HOA from CRIPA and BBOA with my own BBOA of winter. We have also here represent the mass spectra of each factor. Here we can see that for LOA we have this mass of 60, and also it's like BBOA. Okay. Here represent the daily cycle of each factor. As you can see, 2 peaks of HOA, 1 peak on the evening for BBOA and the other. And after the contributions of each factors, always high contributions is to MOA 50%, and here HOA is 13% and BBA also 13.5%. Here for the correlations, we don't have the data of BC fossil fuel and BC was burning for the autumn, so I have just I do just the correlation between factors and sulfate and nitrite. So on this result, I apply the bootstrap with the random e-value 0.5 and some criteria on BBOA and on two oxygenated factors in order to sort in MOA with based on F44. Here I present the factor profile, the mass spectra of each factor and their variation, their time series and weekly variations. For the contributions, as we can see here for HOA is 14%. It's like BBOA and the higher one for MOA with 50%. And the other hand, they present the correlations, but just with sulfate and nitrate. We have a good correlation between MOA and LOA with their tracers. So that's it, and thank you for your listening.
Thank you, Asna. Yeah, you have done quite a bit since you just started. Yeah, I don't remember, but can you just show the winter result with just constraining HOA? Yeah, I mean, not this one, but like I think you showed me before.
Yes.
The one just constraining HOA, 4 factors.
Okay.
You have probably shown me already.
Yes, this one.
Yes. Okay. Yeah, I think Olivia also wrote the email to me about this regard. He thinks your BBOA has too much 43, but too little 44.
Yes.
Yeah, I guess if you get the BBOA like this all the time, then yeah, it's just what it is. But maybe that's I don't know. Hello.
Hello, Jan.
Yes.
Look at factor 3.
Yeah, there's a 44 splitted.
Yeah, with a lot of MZ44 in the second one.
Oh, maybe go 2 slides before 11. Did you just constrain HOA 3 factors?
Okay.
Yeah. Okay. Yeah, this one you don't have 44 in your.
Yes, in my BBOA.
I think we look at this. In each you have run, I think maybe 10. Oh yeah, 10 runs. In every single one, your BBOA have 0.44. Is that correct?
Yes, right.
Yeah, so I think our intention was like trying to get the unconstrained BBOA in winter solution, but it does not. It cannot be done within 3-factor solution. But in 4-factor solution, you do get one. Yeah, but maybe I think Olivia's concern is certainly valid. I think maybe also it's worthwhile to try to constrain HOA, BBOA together, but BBOA not from Sally's, not from NG's, but from Kripa's. You can try that as well with higher 44 in it. Maybe then in your LO, you might have less 44 in it. So then, bootstrap solution in the end, your LO will not have that much 44. I think that's the problem in your current version of your winter solution.
Oh, okay.
But Ian, my email yesterday was more generally speaking at the European level. So, sorry, it's a long time I did not follow. So just wondering if it may be valid for some other sites. That's I'm afraid we miss a bit of oxidized BBOA if we are using NG at some more sites.
Yeah, but like I think it's also a problem if you're just using creepers, for example. Maybe I should suggest them to try both. Which one make more sense, for example? Because sometimes normally it works well, but sometimes it just like if you constrain creepers BBOA in your LOA, you tend to have a fresh BBOA like factor. So we don't really know. I mean, if you can call the fresh BBOA, let's say fresh BBOA factor, a LOA anymore. Yeah, it's normally it happens when the BBOA is a biomass burning is a significant source. Then you tend to, if you want to push to have two OOA factors, it will happen like in your LOA, you will have a lot of biomass burning influence. So if you constrain the creeper, then you end up your LO will have higher 43 than 44. If you constrain NG's BBOA, then in your LO you might have higher 44 than 43. So yeah, that's normally what happened overall.
Maybe it depends on which creeper you are referring to as well.
Yeah, I think it's the Paris winter data, the AMS.
There is one with PTR data which is more oxidized.
Yeah, that one is 44 is higher than 43 if I remember correctly. Yeah, I'm not sure which one you are talking about.
With the same story, I guess BBOA is quite oxidized anyway, and it's not really secondary, it's oxidative primary organic aerosols. It has to be accounted as BBOA. Yeah, but again, not only at this site, but at maybe several sites in Europe.
Yeah. Yeah, this one I don't know.
Our favorite discussion, huh? Fully.
Yes, sure. Not mentioning HOA.
No, I mean it can, but the point of Ian is that shows that there is fresher BBOA. I mean, in some cases, in some locations where you have a lot of BBOA, you constrain a creeper with rather high 44, and then you actually the free factor is then not an OOA, but it's actually much less oxidized BBOA. So that means that this less oxidized BBOA is really real. And somehow, such locations, maybe you just need maybe two factors to explain the chemical variability of the biomass burning emissions rather than two factors for the OAs. And that can happen. And it will include, as you say, some of the biomass burning has different phases, yeah, where you have more F44 and phases where there's much less, and the combination of it is whatever, somewhere in the middle. If it's very inefficient, then there's not that much F44 usually. But yeah, I mean, so it's a bit tough. I mean, I would say at least in such a case, it's clear that you kind of, I mean, you're not doing the right thing. Then call that, I mean, to call that only that factor BBOA when you even have a less oxidized BBOA actually coming up. But if you have two, I think now in the Magodino paper that Ian also submitted, that I mean, there we have, there we have two factors. Yeah, one a little bit more oxidized and less oxidized, and they're likely more, I mean, primary or maybe slightly aged primary. In London, as we discussed before, we saw also this, but I mean, what James discussed is, I mean, they were able to, with the AMS, to extract two relatively non-oxidized BBOA factors to kind of explain the BBOA variability. So I don't know. I mean, there's different types of solutions, but maybe if you have just one factor, I mean, maybe the CRIPA factor is usually not that bad because it's kind of in between, as you say, of the very fresh, non-oxidized and I mean, partially mixed with a little bit oxidized primary fractions. I don't know. So I don't know if that was clear enough, or I was probably rambling too much. But I would be careful if the BBOA gets if you only have one factor and it gets very oxidized, I mean, that's still, I would still say that that's unusual.
Olivia, are you convinced?
I don't know. It's an endless discussion.
Yeah, but like, I mean, I think in this
here,
case,
if you look at this solution, I would say the factor 3 is BBOA influence for sure. I mean, if it's primary or secondary, who knows? I mean, but it's, I would interpret it as BBOA influenced.
Do we have some, I don't know if it's ELF, but do we have some levoglucosan also at some sites we can compare to? Or?
I have it in Magodino.
Yeah.
So I think, but it's offline, and in the future, the levoglucosan was measured by that way, and if I remember right, levoglucosan, yeah, it correlates well with both my less oxidized BBOA and the more oxidized than the one with the more oxidized BBOA.
Yeah.
And yeah, but like, I think when I also add them together to do the multilinear regression with levoglucosan, it also appeared to be better with two OA factors. So basically, you need to prove that you need to like have two factors to explain the biomass burning sources in the winter.
Yeah.
Yeah. So I mean, yes, go ahead.
Yeah. So here's Joel. So I was watching mostly on YouTube, but I decided to join in on Zoom so I can pitch in my this interesting discussion. The thing that I don't know, they seem to follow. There's a lot of this. Maybe Asna, if you can go to the next slide, you can see that there is like, you know, they increase. There's like a peak, like slide 14, where they have the time series. Yeah, you know, for this. Yeah, for example. You know, essentially they come up at the same time, they increase together. So, you know, at first thought, you know, my feeling would be, okay, this is mostly PMF, just splitting this oxidized BBOA into these two factors. Not really so sure, because if it might be having some really oxidized or BBOA influenced LOA, I don't know exactly how to interpret this, but it's clearly like, for example, the MOA there, you can see that there's a completely different time variation, as there's this two BBOA influence, where you have this massive peak coming up at mid-January or second half of January, and then peaks like this. I don't know, PMF can't really resolve that well, so it just splits sometimes, the 44 and 60 between these two factors. Don't know what your thoughts are on it.
Yeah, I mean, one could be tested is for the winter, you can plot the maybe 44 versus 60 to do a scatter plot, or just put them together the time series to see how they correlate with each other, for example. Those are things you can try, and also, I mean, 44-60 plot the scatter. I mean, the 44-60 space, the measure points. I think I have shown you how to do such a plot.
Yes.
Yeah, so you can also try that, and but like certainly here I will try to constrain pre-pause BBOA to see what happened. I mean, at least what the influence on this LOOA. This LOOA's 44 gets smaller. For example, if you have like a more 44 in your BBOA, and those things you can check. But like I mean, here you do in the unconstrained PMF, you do have this kind of, you do see a factor like that, but I mean, here you should put black stars to see what's the contributions for each factor.
Yes.
I think we have been.
Yes.
I have shown you how to do this, but
yes.
Yeah. So just try those first, and I mean, winter solution is always the most important season, I will say. So you have to invest more time on this. But like, I mean, I was still trying to push to have 2OA in winter, nevertheless, because it will really, you won't have too much troubles in the rolling afterwards. So, yeah.
Okay.
But anyway, you have done a great job.
Thank you.
So I guess we're supposed to have a coffee break, but apparently we are 20 minutes late for the schedule. So do you guys mind we have 15-minute break and come back like maybe to 2:35? Is that all right?
Sorry, I'm confused. We were supposed to have the break at 20 to 3.
At 2. We were supposed to have 2 at 2 p.m.
Then I'm looking at an older version.
Yeah. Because Axel is not presenting, so we will be, earlier this time. So I will change it like maybe 35. Then we can finish earlier today.
Good to me.
Oh, and then at 35 we start with a draft.
Yes, exactly.
Okay. Right.
Yeah.
So I had to schedule a meeting during our break, so I will reschedule that. Okay.
Okay. Sorry about that.
Yeah. Okay. See you later.
See you later.